in our strategic plan. So APNIC has done some work around it, starting with historical resources. Now, historical resources are those resources which was delegated pre-APNIC time or pre-RIRs. Those resources where there were no formal agreement, which was not managed under a policy framework. So if you see on the next slide, this would be an example of an old historical registration information. There's no clear indication of who the actual custodian of this resource is. So, and if you see the email and the phone number as well, it might be very obsolete. So in somewhere in 2021, the EC passed a resolution where it resolved that all historical resource holder would need to put all this resource into a proper account. They would either have to be an APNIC member or a non-member to receive registry services from APNIC. So once we were able to help all this member retain their resources, we were able to put all this information, update all this information into a proper account, and this is what an updated information would look like. You would have a proper account name, you have a description of the resource, who is holding that resource, you have the organization org object where it clearly shows where the resource lies, who holds that resource, and then you have your IRT details where if you need to report an incident, you can contact that email, which is regularly updated, or it has to be validated within 6 months. Just to get an overall of the project started with somewhere around more than 3,000 odd cases with around 7 million IP addresses. And we were able to, I think, help custodian retain around 4 million IP addresses. And with South Asian custodian, I think 10,000 of odd IPs were retained by our members. And there are around 2 million IP addresses which we were able to reserve and to be recycled so that we can delegate for future members when they need that. The next improvement we worked on is on AS registration, AS number registration. Now, there are two types of AS which you can take from APNIC. One would be a portable AS number which you would be using for your own infrastructure, and the other AS number would be for your customer or your client. But there are some confusion, or there are some feedback from our members saying it's sometimes hard to distinguish between the two. So the reason could be that organization have maybe some staff changeover, or maybe the corporate contact in that account has left, so or didn't have proper documentation. And I think from APNIC's perspective, I think APNIC did not capture all this information, especially regarding the customers. So the improvement we have done is we have added an extra, example of an old AS number would be something like this, where you have the AS name, you have an organization, but it doesn't show exactly, you can't differentiate between a normal, a portable AS number and a non-portable AS number. There could be instances where you have the customer's name there, but there is, I think other than that, there's nothing much there. So, and the improvement we have done would be to include most of your information there, most of your customers' information there. So now if you're requesting for any AS number from APNIC for your customer, you would need to, or you can add in your customer detail there, and we would automatically pick it up, and then we would update the AS number in this way. So if you see on this example on the left-hand side, you have a separate attribute in your ORG num. You have the org attribute, which shows the customer name, who you have got the ASN for. And the sponsoring attribute is the organization who requested the ASN for their client. So it at least helps you in differentiating or understanding who the different differentiating between the two AS numbers. And the third and final improvement I would like to talk about is the IP geolocation. Now, this problem is a very challenging problem for a lot of new members. As you know, that IP resources are been very scarce, and most of the fresh pools are already exhausted. So all the resources you would be now, if you're a new member, when you're requesting for a new membership, all the resources are delegated. We try to keep it as clean as possible, but there are other sites or other ones who replicate, and they still have old records. So when somebody requests for a resource, we delegate this IP address, and while using the IP address, some of our members find it that some of the content providers incorrectly picks up the wrong address. So that becomes an issue for them. So, but the thing is, when they have that issue, they come to INNOG and they try to understand, and they ask us to change everywhere. They assume that it might be the attribute in their INET num, the country attribute, that they need to change, or is it the two-letter ISO code in the stats file? So they basically want us to come change that. Now, for example, in this scenario, now INNOG only records those country in the country attribute. On the country attribute, we only pick up the country code of where this organization is legally registered. It's not where the network is being used. So similarly, similar to that, in the public stat file as well, that the two-letter ISO code is also just representing where your organization is legally registered. So we thought we would work with this, and we have now implemented a new new attribute called geofeed in our INET num, which is pretty easy to implement. You basically take a CSV file where you input your prefix with the location and the code, and then host it over HTTP either on GitHub or any hosting site you would like, or you prefer, and use that URL and add it as a geofeed attribute in your WHOIS record. And the geolocation providers would automatically consume that information and would have picked it up, and hopefully have you showing it in the correct location. So I think if you go to this website, the geolocatemuch.com, you can see the list of geolocation provider who consumes this data. And I think they have some handy tools as well where you can check whether your geolocation feed is working with that. So have a go on this, and hopefully you can see whether it works. And on these three topics, like the AS improvement and the geofeed. Now we are here at the exhibition hall. Me and my colleague Vivek is there. So if you need any updates to be done on your AS numbers, if you need help, we are there up there. Please do come up and hit us. And I'm open to any questions. Thank you very much for listening. Bye-bye.
Thank you so much, Jimmy, for that very important and crucial presentation. Can we again give a big hand, everyone? Thank you. May I please invite Mr. Rene on stage to felicitate Jimmy, yes, with a token of appreciation. Would request her to please take the center stage. Thank you so much. All right. And now, ladies and gentlemen, it's time we move forward to our next important presentation. And to do the honors, ladies and gentlemen, okay, ladies and gentlemen, before we move to the next segment, just a quick update from our end once again to share all your key takeaways on your social media handles with the hashtag SANOG41 and hashtag INNOG. All right, and now it's time to move forward to our next very important update coming right your way, which is on the NOG and APNIC updates. And to do the same, may I please invite on stage Matsuza from IIJ joining us on stage. Can we please welcome him with a round of applause once again? Over to you, Matsu.
Thank you very much. Not sure, I just asked to coordinate this update session. So I have three NOGs update in hand. So let me start with NP NOG, Nepal. Coming, yes. So in our region, South Asia region, we have a bunch of the country-based and economy-based NOG. So we have a NOG in Nepal, similar to the INNOG here in India. So please come to the stage and give a short update about your activities. Thank you very much. What are yours?
Hello. I'm Rupesh from Nepal. We have a small community that runs NOG within Nepal. We started back in 2016. So these are basically our committee members who are helping us to conduct our NOG. So the five you see on the list were our founding members, and we got our ad hoc team that runs all this program. And we got our advisor, so these are our key people who have been advising us how to run our event and all those. And based on our experience, seeing other NOGs and all those, so we have a couple other teams who actually does the program committee and fellowship committee. And basically we run, these are our stats that we have done till now. So we are on number 9 till now, so we are hopefully doing NOG and coming months, that would be 10. So we basically do two types of NOG yearly. So one is based in Kathmandu, and one we do outside Kathmandu Valley to facilitate small operators who are running. So we need a couple of resources and training as well. So and we did one in COVID, which was virtual event, and yeah, that was quite not productive for us. So, and this is actually our format. We do 2 events. One bigger event happens in Kathmandu, so it's sort of international event what we call, and we call up all the representatives from Asia Pacific who want to come and give any speech or any technology talks. And it has been quite hard for us to find people for presenting in conference and all those who want to show any use cases or discuss about technology. So I would really request everyone here to attend an NP NOC10, which is going to happen in July, and would really like to see your presentation around it. Yeah, so these were topics that we covered till now. So last one we did was for network essential. That actually covered everything that we do in operation in terms of service provider. So these are a couple of photos. Yeah, the last photo is from our NP NOC9 that happened in Saura, Chitong. Thank you.
Thank you very much. Next up is probably from remote, Sri Lanka. They have a Lanka NOG, LK NOG, or is it possible? No, not yet. Then let's invite INNOG. So, oh really? Okay. So I'm interested to do the APNIC update first. So we have APNIC as a registry in our Asia Pacific region. So Baha will provide or recent APNIC update. Was yours and
right, heading towards lunchtime and coming to APNIC update. I'll try and keep the interest alive for the next few minutes, right? As you know, APNIC has an executive council which takes care of the supervisory role of APNIC. You have got Kenny, me, Maz, Archie, Annalie, Sumon, Cams, and Paul Wilson. He is the Director General and the ex-officio member, right? A quick rundown on what functions the APNIC EC does. It represents the interests of members in the governance of APNIC. So this is the most important function we perform. That is, we ensure that the interest of members is kept alive, and all decisions are based on to ensure that they are done on the basis that the membership's interests are taken care of. We carry out oversight of APNIC's activities. We consider the broad internet policy issues for APNIC's strategic direction. We set the membership fees. This is one of the most important functions which we have, is to set the membership fees. Also, we endorse the policy consensus towards implementation. All the policy, you know how the policy changes or policy is made in APNIC through the policy SIG. Well, once the your proposals pass the muster and they are forwarded to EC, we again go through it to ensure that everything is in order, and then we implement it. Last year, we have formulated the APNIC's strategic plan for 2024 to 27. Now, this activity is carried out every 4 years. The EC and the Secretariat work out to develop a new strategic direction to guide APNIC's activities. Now, this is a very important function which APNIC conducts every 4 years to ensure that we remain on the right path. The EC endorsed the new APNIC strategic plan for 2024 to 27. All APNIC activities for the next 4 years are grouped under 4 strategic pillars, right? I will come to those pillars. The 2024 activity plan and budget describes the activities according to the same structure. So, coming ahead to the strategic overview, see what we have done is, we have created 4 pillars, which we name as value streams. Value streams are 2, that is registry, which is our foremost function of APNIC, and the developmental requirements that APNIC is required to do. So these 2 are the value streams. And then we have the enablers. The enablers are the engagement, that is engagement with the community, engagement with other organizations, and the capability. So these are the 4 pillars on which APNIC functions. Also in these, what we have done is, we have made the senior leadership team who are taking care of each of these pillars fully responsible for the functioning of their respective pillars, as well as we have ensured that they have the financial support to run their duties. Now coming to a quick update on finances. The 2023 audited financial statements approved and presented at Apricot in 2024 in Bangkok. They have been released, they are with you guys. I am sure you all must have had a look at it. APNIC has been functioning on a bit of a deficit on losses. And however, we were able to save fair amount of money in last year. And the budgeted deficit we had expected was 1.1 million, but we were able to limit it to 500,000 or say a little less than 600,000. Net surplus after gain on investment portfolio, our investment portfolio earned some money. So we have a net surplus of 1.08 million. Overall membership growth from the budget assumptions as of 31st December 2023, APNIC had 9,944 members in 53 countries. The approval of activity planning and budget for 2024, commitment to restrain year-on-year expenses growth to 4% or less. We have really worked very hard. Maz is our treasurer, and we have worked very hard to restrict our expenses. A lot of things, a lot of changes have been done to ensure that our expenses remain very well in control. Financial reports of 2023 are available in the annual report. Right. Coming to the APNIC membership, if you see, Australia has about 2,515 members. Bangladesh has got 1,594 or say 1,600 members. Now, they have got a large chunk, followed by Hong Kong, India, New Zealand, and the other countries. So today, total of 10,041 are there. Now, every year, 2 years, we conduct a survey, right? Now, this survey is very important. We consider it a very important function because it is through survey that we reach out to the community, get ideas from the community, get their concerns. Those are presented, and APNIC very seriously takes actions on all the points that have been raised by the survey. So this survey is independent and anonymous. It gathers feedback from members and community about APNIC's performance, priorities, and future activities. In the last APNIC meeting in Bangkok, we conducted the survey, people conducted 48 interviews. In this year, June or July, we will be releasing the online survey. The report will be presented in Wellington in New Zealand when we get together in September this year. So please do take part in the survey and give your feedback. The other important APNIC update is that the DG, that is Paul Wilson, has expressed his desire to retire, We are in the process of identifying a new candidate for that position. Serious work is on it. APNIC has formed a DG search and transition subcommittee to manage the process. We have appointed an executive search firm called Johnson Partners to conduct the search. So any inquiries that you have, you must get in touch with them at the email address which is given. The EC reiterates its appreciation to Paul for his distinguished service to APNIC members and the wider internet community for more than 25 years. Right. There's another important announcement that we had, which has already been released as a blog. It was already released earlier also. Just to remind you that we decided that the 12-year moratorium which had been placed on creating new NIRs, we have stopped that. So this is now permanent, so there will be no more NIRs raised by APNIC. However, this change will not affect the current NIRs. They will go on as business as usual. The original moratorium was passed in 2012. The economic conditions and benefits for the establishment of new NIRs has since declined. Establishing new NIRs is no longer suitable. About APNIC conferences, the next one will be held in Wellington, New Zealand in September 2024. The workshops are from 30th August to 2nd September, while the conference is 4th to 6th September. Apricot will be held in Dhaka in Bangladesh in February 2025. APNIC 60 will be in Da Nang, Vietnam. We hope to see you there. Member feedback. The EC welcomes comments, suggestions and questions from members, stakeholders and all others with an interest in APNIC. EC submissions can be done via the My APNIC account. Contact form can be filled on the APNIC website, or you can contact the APNIC staff or APNIC EC who are present there for the respective conferences. Any questions? I am available.
Thank you for her. So as an EC, we are always here to listen to your feedback. So if you have any comment, please contact us. So next up, it's maybe the last but not least, INNOG. Because we have some idea about an INNOG already, but as we have an INNOG community now, it's a great opportunity to share some of updates.
So, Pankaj Chaturvedi representing INNOG. So I already talked about the INNOG yesterday, so I'll just recap a few things here. That this was SANOG41 along with INNOG7. So we've already had 6 INNOGs in the past. One we couldn't do during the COVID period. So 6 were done, and out of that 2 were online and the 4 were in person in Delhi in India Habitat Centers 3, and 1 was IIT Delhi. So in terms of this SANOG, INNOG 7, we've had some 350 registrations. Out of that, yesterday around 260 people had attended the conference, including the exhibitors. And today I see there's a thin crowd, but I do see people on the exhibition crowd, so I'm hopeful that at least 150 people will be here today. And today being the last day of the conference, I hope that you all have had great conference, and some of you who also attended the workshops had a great workshops. And my humble submission again to everybody is to subscribe to the mailing list of innog.net as well as sanog.org to keep get the updates on the forthcoming events. At INNOG, we also do tech sessions. Many of our trainers here in India and the APNIC trainers were on our request hold tech sessions, which are generally which are held online. So those you would get to know only on the mailing list. So I urge everyone to subscribe to the mailing list of both INNOG as well as SANOGs to keep the updates, and hope to see you in the next INNOG. Thank you very much.
Thank you, Pankaj, for the update. So before concluding this update session, is there anyone who want to make a comment or remarks? It's open to the floor. If nothing, let's conclude the session. Thank you very much.
All right, thank you so much, Matsu, for leading the session, and to all our presenters for joining us on stage. May I please invite Matt Jensen, Lead Edge Strategy APAC at Meta, to felicitate Matsu with a token of appreciation. Can we have a big round of applause? Well, I would also urge all our members of the audience that if you all have any questions, yeah, first a big round of applause for them. And yes, if you all have any questions, do connect with our speakers offline. I'm sure they'll be more than happy to answer all your queries, because this is the platform, this is the day where you get to connect with our speakers and get all your queries resolved. On that note, ladies and gentlemen, it's time we now break for lunch. It is 1:40, so I would urge you all to please join us back at 2:30. We break for 50 minutes, and I believe that time is the biggest asset to each one of us. So I would urge you all to please join us back at 2:30. In the meantime, we have our exhibition booths right at the second floor. I would urge you all to please connect with our exhibitors, and they would be more than happy to connect with all of you. And yes, do not forget to share your happy pictures, your smiling pictures, and your updates on your social media handles with the hashtag SANOG41 and hashtag INNOG. Please have a good time, and I will see all of you at 2:30 sharp. Thank you. Assemble back into the ballroom as our speakers are right here waiting for their next presentation. I would request everyone to please take their seats. A quick request to all our members of the audience in the pre-function area as well to join us back. We have yet another very vital and crucial technical presentation coming right your way. All right, ladies and gentlemen, I believe we are good to begin with our next technical presentation. But before that, I would like you all to please have a look right here at the stage because we are about to begin with our presentation. So can I urge everyone to please put your right hand up if we are ready to begin. I see only few hands coming up. And I want to listen a louder yes before we begin. So are we ready to resume? Oh, this is not the energy that I need. I need more energy coming here. Are we ready to resume, ladies and gentlemen? Okay, one more time and then we begin, okay? Are we ready to resume? All right, so on that note, let me welcome our speaker on stage who would be leading and chairing our next technical presentation. May I please invite on stage the Senior Program Manager at Microsoft India, Mr. Saurav Satpathy. And now that I have your attention, you're at the stage. Can we have an attentive round of applause for Mr. Saurav? Come on, everyone. Thank you.
Okay. The stage seems to be dicey, but yeah, I'll prefer to stand the down. Hi everyone, Saurav here. I'm full-time working with Microsoft as Senior Program Manager, but here as an AppNIC CT as well. I have a technical session to be chaired where we have some presentations and people to speak around Akamai from Akamai, Equinix, and from Web Surfer Communication Private Limited. This session is going to start with little bit of understanding towards how CDN optimization and performances happen. And the second and third are more towards the network operations optimization, and that's where Equinix and Web Surfer would contribute to. So please please let us invite Priyam Abhishek from Akamai to talk on the topic of optimizing traffic flow with Akamai. Please put your hands together for Priyam, please.
Hi everyone, thanks Saurabh. So my name is Priyam. I am working with Akamai as network consultant. So good to have you all, and I really thank the SANOG PC for arranging such a good event. So yeah, let me start the presentation. So I basically want to go through how Akamai helps in optimizing traffic, the ISP's traffic, and how CDN helps in reducing their transit consumption, and how we contributes towards internet scalability and a good edge performance. So yeah, so the topic that I would like to cover here is where all Akamai is present in South Asia, and then how Akamai works, and what are the best practices that we recommend to the service providers, to our partners, and how we contribute in that manner. So we are basically present in quite few countries, 8 countries in South Asia. We are in Afghanistan, we are in Bangladesh, primarily in Dhaka. We are also in Bhutan, in Maldives, in Nepal, in Pakistan as well, and in Sri Lanka, and leading with India across 40 cities. And we have quite deep penetration, and we are not just into metros in India, we are also into the remote cities and the smaller tier 2 and tier 3 towns as well, to have more and more deep coverage to the eyeballs. So yeah, how Akamai works is what I would just run through. So you might wonder at times that are our clusters, the Akamai CDN clusters which are deployed in the ISP's edge network, so are they backbone connected? So most of our clusters, the cache nodes that we deploy, they are not backbone connected. They don't talk to each other. Most of our clusters. There are some locations where Akamai is there, having backbone connectivity, but they are majorly present in the carrier neutral facilities. And those clusters of ours are backbone connected, but yeah, 90% coverage that we do are the clusters which are isolated, independent, and they don't talk to each other. Then I would also like to go through where does the Akamai content come from. So we basically try to fetch the content from the parent servers, the origin server, from the content owners. So say if abc.com is a content that Akamai hosts, so the original request from Akamai will go to the parent server. It will be cached to the local servers that we have deployed across ISP's network, and also to some mid-tier servers. So I'll go through what mid-tier servers are in my next slides. And how does Akamai direct the users to its cluster? So we are a complete DNS-based CDN. So we are not working on any caste based mechanism. We only operate on DNS-based CDN mechanism, where where if an end user requests for, say, a content, the request goes to the local cache of the ISP's recursive server. Then it goes to the Akamai's authoritative server, which is addressed by the CNAME. And from there, we return an IP of the content that is requested to the ISP's local resolver. And with the resolver IP, the end user is able to then fetch the content and access the content actually. So this we also typically call as mapping, Akamai mapping. So this is our primary working mechanism as well. So yeah, as I mentioned, we have primarily we have two types of clusters. One is private and the other is public. So private clusters are the one which are dedicated to ISP's premises, I would say. And they are dedicated to serve the on-net routes and the downstreams of that particular ISP where the Akamai cluster is present. So they are the private clusters and they don't have backbone connectivity. They reside in the ISP's own network, and the ISPs with whom we have such sort of arrangement, we call them as AANP, Akamai Accelerated Network Partner. Then we have public clusters. Public cluster as in, say, in STT. We all know Equinix. We all know some other career-neutral facilities. So there we have our presence, and the infrastructure that we have over there is larger because the kind of traffic that we serve from the public cluster, they are basically the mid-tier contents that we fetch from the parent or the origin servers. So the kind of transit that is required, the transit connectivity which is required to fetch such content is huge, is humongous in fact. So we require a lot of infrastructure, a lot of high footprint servers, and such sort of transit pull cannot be, demanded from the ISPs. So we basically tend to take care of that transit load, the transit cost, and we deploy our own infrastructure in the career neutral facilities. So those are the public clusters, and they are basically destined to serve the mid-tier, some edge traffic, and as well as some of the HTTPS traffic as well. So if you see here in the shown diagram, so if an end user is connected to an ISP network, the ISP network can avail Akamai traffic through the bilateral peering that we have in the common IXs, then through their own transit, and in their transit, say ISP A has a transit as ISP B, Akamai will have a presence in ISP B as well. So that particular ISP will be able to get served from the transit connectivity as well. The ISP A will also have a private cluster if they are, qualifying for certain traffic criteria, Akamai traffic criteria. And at the transit network, we have the private clusters as well as the public clusters. Like say in STT data center, if we are having our public infrastructure deployed, so the end users can fetch the content, such specific contents from their ISP network via the IX peering or the transit connectivity or the PNI. So apart from the private dedicated cluster that we offer to the ISP, we also offer private connectivity, which is also known as private network interconnect. So via PNI, one can avail the Akamai traffic at the public clusters. And yeah, as I mentioned, we fetch the content from the from our own transit that we own and take care of, and they are connected via our backbones to our public clusters. So how Akamai works? So if we are taking care of the edge traffic, the day-to-day edge traffic, so we cache the content and distribute them to the end users. So how we do that? So edge traffic can be present in the public clusters, it can be present in the private as well, because the transit required to cache in the contents is not a lot for the edge traffic. So we prefer to deploy our own setup, our own cache nodes in the ISP's network, and from there the contents are fetched, and the end user can then access Akamai hosted contents. So if you see here in the diagram, so I have shown a kind of very brief pictorial representation of how Akamai works. So the end users can be connected to the private cluster and can avail the, via the ISP's own network. So, and they can fetch the edge traffic. They can also be connected, the end users can also avail Akamai traffic through the PNI that we have with their service provider, and through the transit as well. So say if an ISP does not have Akamai cache node because of the low traffic that they have or due to certain circumstances, so they can avail Akamai traffic, or they can serve their end users the Akamai traffic via their transit. So say ISP A does not have Akamai, but if ISP B has Akamai cache node, so we can serve the end users of ISP A via the transit of via their transit from ISP B. So that's how Akamai works for the edge traffic. So yeah, as you can see, the edge traffic can be served from the private. The green lines show from where all they can be served, they can be fetched. And the fetching is from content, and it can be served via the private cluster, the public, and the paths to avail that traffic can be IX, transit, and PNI. And these are the three main connecting links that we use to have arrangements with the ISP, either by having a private cluster in their own network, or via IX peering, or via the PNI that we have with them. Then comes mid-tier traffic. So there are also certain traffic types which we try to pull from the parent servers, the origin servers. But say if the origin server of abc.com, if that resides in say US, and we every time while if a new end user tries to access abc.com, so the fetching will be done from the US origin server. So it involves a lot of latency. It will not give the kind of internet speed which we are habituated of. So what we do, we try to bring those origin servers closer to the edge network, so that the latency is reduced, the internet performance is scalable and is good. So for that, we deploy our mid-tier servers, we say mid-tier clusters in public deployments, like in STT data center or in Equinix or wherever we are present. You can see that in the peering DB data. So we kind of we tend to deploy our mid-tier infrastructure in those clusters, and if an ISP has PNI with us, they can avail those mid-tier traffic via that public cluster of Akamai. Okay, the other thing that we usually get to hear a lot is why certain BGP traffic engineering doesn't work with Akamai. So the thing is, Akamai, as I mentioned earlier, is a DNS-based CDN company. So if we were working with the mechanism of anycast routing, we would have supported certain BGP techniques like AS path prepending and configuring the MEDs, and somehow try to manipulate the BGP routes to prefer a certain path. But with Akamai, that doesn't really work for most of the time. So I would mention the reasons for that. So our basic criteria to serve traffic or to map traffic to a cluster is based on network performance. So the first and foremost parameter for us is latency. So if the latency is closure for an end user to be served from location A, despite having that particular ISP's own bandwidth larger at location B, Akamai would prefer to serve the content to the end users of ISP A from location A, for that ISP from location A, because of the latency. Also, if the last mile connectivity, I would say, if that is optimal, we would try to select that path where the packet drops is less because of the KPIs that we monitor for the customers that we host. Then the server capacity. So say at times the situation might happen like an ISP is having Akamai cluster in their own network, but certain contents that might not be served from that particular dedicated cache node. So the reason might be the server capacity as well, because certain contents which are which consume high footprint and they need a lot of serving capacity cannot be deployed in every ISP's own network. So we tend to have such larger infrastructure in either the giant telcos, where the end user traffic is in TBPS or hundreds of gigs, and that is why most of the ISPs can sometimes, some of the ISPs I would say, not most of the, but they can sometimes feel like why my content is getting served from the transit but not from my own cache. So the reason for that is the server capacity. Then the cache placement policy. So we tend to have our own policies, internal policies, based on which we decide where we place what cache and Also that the traffic criteria that we have defined to deploy cache node for a certain ISP, for in fact all the ISPs across a certain territory is different. So say in APJ we have a certain traffic criteria, and based on that cache policy we define if we are going to deploy a CDN in that particular ISP's network or not. And then if we are deploying an Akamai cache node in their network, we have again a certain criteria of what kind of cache contents can be mapped to that particular cache node because of the throughput the deployed servers are giving. So that cache placement policy is also a deciding factor on how Akamai maps traffic. And then the cache serving policy, which I already have covered. So yeah, this is how the typical Akamai network can look like. We can have our private clusters in an ISP network. Then we can have public clusters, and an ISP network can avail Akamai traffic via their IX peering, transit, and PNI. And then we have our public clusters and at the transits and at the carrier neutral facilities. So yeah, if we talk about why certain traffic engineerings they don't work with Akamai, so the simple reason is that we are DNS-based CDN, so the traffic doesn't run on the BGP peering. The peering that we have, it's basically to learn in the on-net routes of ISP, so that our mapping algorithm can decide, okay, these many end users are getting learned from this ISP, so we have to map them to this particular ISP's dedicated cache node of Akamai. So the AS path length is something that we don't consider as a parameter to serve traffic. So AS path prepending might not work to just manipulate a longer path and make it not serve from, make it not select for that particular ISP. So those fine tunings might not work with Akamai. Similarly, as I mentioned earlier, the MED value, the multi-exit discriminator. So an ISP can wish to have a lower MED value for a certain path and prefer that particular AS path to serve their traffic. But it might not work with Akamai because what we tend to have is the latency parameter or the performance of the link or the cache placement policy or the serving capacity of the cache node. So even if the say transit network is if an ISP has say 2 transit networks, they have 2 transit providers, and they don't want to prefer transit provider 1, and they want to just prefer transit provider 2. These fine tunings might not work because Akamai parameter might give more better latency, optimal latency to serve that particular ISP from transit network 1. And the prefix length is also something that we don't incorporate. So advertising a specific route doesn't always work. It sometimes works based on the fine tunings or the adjustments that we do, but we don't really encourage announcing specific routes to us. We basically encourage our ISPs and our partners to announce us in /24 format, which is generally a globally accepted prefix length. But yeah, sometimes a few BGP traffic engineering might help. Like say, if I've shown here in the diagram, if you see, say ISP, this particular ISP doesn't want to be served from transit network 1 because of their limited bandwidth or the transit cost that they are paying. So they can request Akamai that, hey, I don't want my Akamai traffic to be served via transit network 1. And I would rather prefer to be served it via transit network 2, which has, I have a larger bandwidth with them, or just because of my internal networkings. So Akamai can, apply some traffic engineering to de-prefer the transit network 1. And we can also encourage the ISPs that you can apply certain fine tunings at your end to de-prefer your congested transit provider link, so that when we try to reach out to the cluster of the cache node of Akamai, the transit network 2 is preferred. Yeah, so the same thing has been explained here as well, that ISPs can feel free to adjust their network routing so as to prefer a certain transit provider. But yeah, it needs Akamai's end optimization also, because we will then apply some sort of preferences to a particular link so that the particular requesting ISP is served from the path where they want to be served from. So yeah, as I mentioned, why don't these techniques have usual effect? Because we are DNS-based CDN, we don't exchange traffic on the BGP peering that we do on the private clusters. The criteria that that we incorporate is latency, throughput, packet loss. We use the DNS mapping to decide where to serve the traffic from and how to serve that traffic. And we suggest the ISPs to, incorporate and accommodate the best practices and recommendations that Akamai suggests. And we encourage everyone to reach out to us and, let us know their issues, their constraints, and we try to collaborate and work together to find a consensual solution towards traffic optimization. Yeah, so the best practices that we recommend to the service providers and the ANPs that we have is setting up own DNS resolvers. So that is the first and foremost kind of requirement that Akamai releases, is to have own DNS. Yeah, so the own DNS will help the ISPs to have their end users request resolve at, and Akamai will learn their DNS IPs via the BGP session that we establish, and that is how it works. We also support Google DNS, OpenDNS, because we have eDNS 0 solution implemented with that. And as I mentioned, we encourage ISPs to announce their DNS, announce their on-net and downstream routes to us, and map so that we can map their traffic based on the DNS that we learn, the downstream routes that we learn. And yeah, the consistent route announcement, the globally accepted route length is what we encourage the ISPs to announce to us. And yeah, what we request our partners is not to filter the traffic, not to apply any sort of, AS path prepend or announcing specific routes to us like /23 or the pools which are not globally accepted. Even with the IPv6, we recommend the same to announce as the /48 ones, because they are the ones which are globally, advertised. And yeah, we also have performance monitoring IPs which represent the ISP's DNS in case the ISPs have incorporated certain rate limit policies on their DNS IPs. So Akamai mapping system scans a nearby monitoring IP to that DNS, and we try to send ICMP packets at certain ping rates, and we try to just see if the edge network connectivity from global internet towards that monitoring IP is stable, and that is how we map the traffic to. So if possible, we encourage the ISPs not to apply any sort of monitoring, any sort of rate limiting policies on the monitoring IPs that we select or we ask from the ISPs, from the partners. So yeah, this is how Akamai supports. We have a highly distributed edge servers. We work on DNS-based mapping. We do support certain traffic engineering, but yeah, the best practice is to have your own DNS resolvers, maintain and announce as your complete on-net routes, your DNS, and not to filter any sort of traffic. So yeah, any questions, you are welcome and encouraged to reach out to me. Yeah, Anurag.
Hi, Anurag Bhatia, Hurricane Electric. Thanks a lot for the great talk. On the DNS resolver part, you had only the 8888 and OpenDNS, essentially the ones which support client subnet EDNS.
Yeah.
Just curious to ask you, if someone is starting up DNS resolvers, setting up OpenDNS resolvers now as an entity, can they work out with Akamai to support EDNS client subnet? Because I think by default, you do not accept it for everyone. You accept it only for few resolvers where you have some agreement in place.
Yeah, see, we basically support the DNS which are incorporating the eDNS 0 solution. So why we recommend Google or OpenDNS is because we have eDNS 0 configured with that. And that is why those DNS servers, traffic coming from those, I mean the DNS lookup that works with OpenDNS and Google DNS can be mapped with the Akamai clusters that we have. Using certain private DNS or third-party DNS might not be serving the purpose because we are not learning the geo feeds via them. And
if it's a fresh DNS which has been set up now, a new DNS resolver, it is supporting eDNS 0.
yeah, that can work.
Will authoritative pick it up by default?
Not by default. We can work on it to follow our RFC 8805 format, where we can learn the geo feeds from the ISP's network, and that can help serve the Akamai traffic from the network they want to have.
Essentially, it's a manual process where they reach out and make it work out with you specifically.
Yeah, it can.
Okay.
Yes.
Yeah, hi, Gaurav Kansal this side. So first is, I think it would be great if you would show the India map correctly in your presentation, at least if the presentation is in India. So the map was not showing Indian map in the first two slides was not correct. Now coming back to the technical point, I have a question like Akamai is heavily based on authoritative DNS server. And because every website which wants to be hosted over Akamai has to CNAME to Akamai DNS servers. So my question is, consider a case where internet connectivity of India is maybe the uplinks streams of all the C-links pipes fiber are disconnected due to any reason whatsoever. But within India everything is okay. So whether the sites which are hosted over Akamai will work or not?
Yeah, they will work. See, if there is any outage, where internet connectivity is broken, we try to find the next optimal path from where we can serve the demand to.
My point is connectivity, only the C-links connectivity going out to India is broken, not a connectivity within India. So all up C fibers are broken.
Yeah.
Then in case, because you serve the user based on the DNS approach. So maybe ultimately the decision will be taken by the DNS brain, the top brain of yours. So if I am not able to reach, because maybe your presentation does not mention whether the brain is within India or not. So question is whether the Akamai thing will work in case connectivity, C-links are disconnected, everything else is working. Like I am able to reach everywhere within India, but not outside India.
See, it depends. If the C-links, you are basically mentioning about the C-links if get disconnected. Yeah. So how will Akamai be serving those traffic, those contents which are?
No, not the content. It's just because how you will, because every decision is taken by your DNS brain.
Yeah.
So whether that brain has a presence in India and whether that brain can even if that brain is disconnected to the world, whether that DNS brain of your Akamai will be able to decide where to route the client for any website or any.
Yes, we do have. I mentioned in my slides earlier, Gaurav, if you would have seen, we try to cache in some of the parent contents to our local in-house capacity. Within India, if say certain origin contents are residing to across sea borders, where the subsea cables have been disrupted. So Akamai has that algorithm and the logic or the mapping intelligence to find out the best possible locations where those certain DNS resolvers can be mapped to, if not via the C-link connectivities. So the algorithm is there to serve via the alternate routes.
We can discuss this.
Yeah, sure, we can discuss. I think, any questions? So thanks everyone. I hope it could have made some clarity with the presentation that I just presented here. So thanks all.
Thanks, Priyam and Akamai team for presenting and giving us insights on how Akamai network works and how do they help ISPs optimize their network traffic as well. Next in line, let's put our hand together to invite Mr. Nihar Ranjan Panda from Equinix. The topic for the technical session is multi-cloud networking, addressing architectural challenges. He would basically cover what are the various challenges with the multi-cloud networking that the service providers or any exchange providers see, and how do we overcome them. So let's put our hand together to welcome Mr. Nihar Ranjan Panda.
Hey, thanks, Saurav. So, good afternoon, all of you. My name is Nihar Panda, and I'm representing Equinix India. I lead the digital pre-sales for Equinix here in India. I know it's like late afternoon almost, and I thought I'll start with a little joke here, right? So it was only yesterday, I was watching a referral YouTube link. How many of you are really aware of what cloud seeding is? I'm sure all of you would know, right? So literally, a gentleman and high-ranking official, I won't say which government it is, but high-ranking official was explaining cloud computing on YouTube. And literally, he equaled that to what we call as cloud seeding. You know, your data goes to cloud and how data is retrieved from the cloud and how it would get lost if it rains. Now, there's a literal video there, and there's so many likes. So please watch it if you get time. Okay. Now, I'm sure we are not here, at least at that level, we understand what cloud is. What I would like to cover in this next 20, 25 minutes is very simple, not to bug you technically at this time of the day, very simple business problem with multiple cloud adoption for an enterprise, right? And we'll look at some different challenges, particularly with respect to networking, how enterprises adapted, cloud service providers over these years from the last decade, let's say, and how they have been able to address those challenges and how we as Equinix helping them to overcome those challenges, right? Right, so I'm sure you all must have heard this word called bill shock. Can I see some raised hands as to bill shock with, in reference to cloud service providers, cloud bills? How many of you have heard this word before? Can I see some raised hands, please? None? You haven't heard of bill shock? Okay. Now that's interesting, right? So let's walk back at least 10 years, right? So 2024, let's go back to 2014. And then fast forward to 2015, 16. What is the state of cloud adoption? How many enterprises or your customers or yourselves were working with cloud service providers at that point of time, right? Whether it is AWS, which is a newcomer, or GCP, or Azure, or for that matter, any CSP, right? And we all are aware at that moment of time, enterprises are so very enthusiastic about cloud, right? And there were definitely incentives at those times to move into cloud offered by the CSPs. And of course, there's a frenzy around, there's a hype cycle that they're going through. Now, fast forward to 2021, right? From 2015 to 2021. At least the enterprises that we interact with, and I'm sure quite a few would have been interacting with, you'd see that most of them are re-evaluating their strategy as to what should they do after they have seen their bills. Because for 3 to 4 years, the bills were totally ignored, right? And it went all the way up to boardrooms in 2021. It was just shock. And one of the shocks, I'll actually talk about those shocks as what components in that bill actually turned out to be shocks, right? And to circumvent around that, service providers, at least in 2018-19 timeframes, opted for moving into multiple clouds. And in fact, if you look at the statistics from Flexera or Oracles of the world, you would see that 90% of enterprises, actually more than that, are using more than one cloud today. It's only 5% who has on single cloud, who are on single cloud, right? Now, that kind of addressed some of the challenges in terms of bringing an economic stability or economic advantage, but then one challenge that came out very visibly, and that's multi-cloud network. So moving workloads from one cloud to another, distributing workloads between your on-prem, your co-location, your cloud, it's all fine, but end of the day, you need to interwork with them, interconnect them. And that's where the challenge was, right? And this is something that we're going to focus on for this next 20 minutes, okay? So before we even move there, let's spend about a couple of minutes understanding how usually enterprises connect to cloud. I'm sure you all know it, just a refresher maybe, right? So first principle, when cloud was launched, even today, small enterprises, how they connect to the cloud, right? Simple IPsec tunnels, right? It has to be secured, and it has to be at least dual tunnel configuration. Almost all cloud service providers recommend, and some even compel to do that, right? So you have two IPsec tunnels originating from the enterprise premise all the way to the cloud gate, right? But doesn't matter which cloud gateway it is. The second way, then the challenges were, of course, we'll talk about the challenge again. The second way they connect to the cloud is via NSPs. Now, obviously, there are deficiency of connecting over internet, right? And you can possibly count them, right? Like bandwidth limitation, like the overhead that comes with your securing the tunnels, which is IPsec, right? And of course, latency, because it's not a guaranteed path. The second way, so the CSP is innovated and the enterprises worked together and they found, okay, why don't we directly connect with each other if the bandwidth requirement is really high and we want to be connected privately? Perfect. So then came the NSPs in between, who would actually on-ramp or bring those enterprises to a co-location center where they can be connected to a cloud operator directly. When I say directly, it's a passive one-to-one connection, okay? If you know what the cross connectors, you know, just put to point A, point G, and just cross-connect them. Simple. 1/10/100G. Done. Perfect. That was a good way to connect. And that kind of solved a lot of issues. The third way, which is the current trend, is basically to go one step further to bring on that flexibility that is required in order for the enterprises to scale up, scale down. What it means exactly. So earlier they were connected 1/10/100G. So even if it is overutilized, underutilized, nobody cares. You have to pay for the cost, right? And obviously it used to take its own sweet time to get connected. However, with the third option, the enterprises had the option to actually on-ramp or scale their bandwidth requirements up and down as they want. It's an on-demand basis connectivity. What usually service providers would call hosted connectivity. You know, different providers call it different way. AWS calls it direct hosted connectivity. Google calls it, partner interconnection. Oracle calls it fast connect, and so on. Azure calls it express route, and so on and so forth, right? So perfect. Now all these three, we'll look at challenges associated with all the three of them, one by one. This challenge number one, very simple. So I unwrap my cloud connections, I distribute my workload between different cloud operators because I'm multi-cloud now. And I will have IPsec tunnels originating from my on-premise to the cloud operators, all the three. Now, when I say split stack, if you don't know, no worries. Split stack is nothing but converting a monolithic workload into a microservices workload basis, or you kind of bring, I'm sure everybody have heard of what is microservice cloud native and so on and so forth. So you have a big monolithic application with front end, back end, and so on and so forth. You actually decide, okay, no, the entire application stack now need to be divided into smaller microservices so that I have better control and better modularity over the application. So depending on which cloud service provider is better in what kind of workload, enterprises now started distributing the workload across the CSPs. Now that's what we call a split stack application. Now in this diagram, you would notice that it is not about always traffic communication requirement between the on-premise and the cloud operator, but between the different cloud operators. So you got both north-south as well as east-west communication happening between the workloads, right? But here's the problem, right? What is the problem statement? So I'm sure being networking folks, you would know what is traffic tromboning, isn't it? Where, let's say, a big data app on GCP really needs to extract data from the data lake, which is at AWS S3, right? So the communication is happening between GCP and AWS. It need not always go back to the enterprise and then come through to AWS. But that was the case. So where traffic always has to go back to the enterprise or the HQ and then come back to the destination, right? So there is a huge latency implication and cost too, right? Apart from that, of course, internet, as I've already mentioned, you got your own overheads of, employing tunnels, secure tunnels, and then per VPC, you usually have 2 tunnels, so you know the cost. And lastly, the bill shocker. And if you have never heard of it, that is the egress costing. I won't say it is the CSPs who are responsible or the enterprises who are solely responsible. I think it was the responsibility of both parties at that point of time who did not account for it. So egress costing being actually it bears the largest amount of your bill. Okay, what is there in the cloud, you have to take it out, you pay for it. You don't have to pay when you have to push data into the cloud. You have to pay when you take data out of the cloud. And that's egress costing. And that's probably the highest, consuming, bill component on the bill. Okay, component of the bill. Looking at the second challenge, right? Now that is about connecting over internet. Coming to the direct connect, right? To cross connect, 1:1, passive interconnection between the colo or via NSP to the facilitator like Equinix or any other data center provider where AWS or all these public cloud service providers are co-located. They built that network POPs. Now in this case, what are the challenges, right? The traffic tromboning still exists because traffic still has to go back to the enterprise headquarters and come back. That didn't go away. And the process, if you're not aware, how do they interconnect? Actually multiple steps. So the enterprise will raise a request of direct connect with the CSP. CSP will provide an authorization letter. That letter would go to the NSP who would actually bring the enterprise into the data center. And then that NSP will provide another LOA to the data center provider or the facilitator who would interconnect. Anywhere between weeks to months of process. That is the second week, which was the case and which is even the case for quite a few enterprises would prefer to do it that way still, who wants dedicated direct interconnect. Of course, admin and technical overheads. So enterprise has to manage its own routing and peering with the cloud service providers, maintain the assets, the logistics of it, whether it is colo or whether it is even their own HQ. Right? So the only thing that enterprises got away with this approach was the egress costing. If you would know, the egress costing is almost less than 50%. Actually, it is more. In some cases, it is even free. The egress cost is free over direct connect, particularly for, let's say, OCI, for example. They offer free egress up till 10 terabits. 10 terabytes, right? AWS, GCP, Azure has substantially reduction over pricing over egress when they are connected directly. So that part is definitely taken care of for the second approach. And lastly, the third approach, which is the direct hosted connection. This was the ideal way, right? And I think every other service provider, be it Equinix or anybody else, has this offering today, okay? And most of the enterprises would prefer to connect to the cloud service providers this way. That is, by having a virtual connection to the cloud provider through a facilitator, through a service provider like Equinix, okay? Now, these are typically layer 2 on-ramps with the cloud provider with the option to upgrade, downgrade bandwidth on the fly if the provider offers it. Like, for example, in Equinix kind of offering, It is totally on demand, and on the fly, enterprise can, upgrade, downgrade their bandwidth, depending on what bandwidth ranges that are offered by the CSP or the cloud service provider. But still, challenges are there. And what are the challenges? Traffic tromboning is still there, because all that happened is we moved from internet to dedicated passive connection to now layer 2. But that didn't take away the problem of traffic tromboning that is going all the way back to the HQ and coming back, for east-west communication at least. And the admin overhead still remaining. So what is the way forward? Right? What is the way forward? Now this is what an idealistic approach. Somewhere some providers are, have reached that point, and at Equinix we are thriving always to be here and better than this though. Now what is this approach? Instead of having traffic to travel back to the source of request or source of workload, it can be steered locally. How? Very simple. Put a router there. Right? Put a simple steering device there, and steering device in this case could be simple router. Now, but simple router is not simple. So let's say a co-location, and this point is valid, assuming this point is valid where you want to steer traffic locally. Buy a router, put it into the data center. Now that's again not simple. A router doesn't matter how small, how cheap it is, you still need a rack, you still need space, you still need power, you still need an agreement and commitment. So that really does not solve the real issue. The issue is how can I be faster? How can I on-ramp to the cloud as smoothly as possible? How can I have that agility to move across my bandwidth requirements? So those things are still not addressed. So how does that get addressed? So is there a way that I can still have the possibility of spinning up routing solution without having to buy an appliance, a router per se, right? Or router, load balancer, or firewall per se. Can I still go in the VNF way? Can I have NFVI or NFV, network function virtualization infrastructure, which could allow me to spin up a VM instantly on demand basis, and I should not be committing to it? I might have a very transient requirement of data migration for, say, 1 day, 24 hours. But do I still need to go and commit for like a year? No, that probably doesn't work, right? So can this happen? Yes, this can, right? So if you have an option of, or the enterprise has an option of spinning a function, network function that meets the requirement of steering traffic from one cloud to the premise or between the clouds, that's also purpose, right? Thirdly, how fast can I spin up those VNFs, right? As long as it is orchestrated, it is automated, it's API driven, you can. And that's what we do exactly at Equinix today. Okay, we allow enterprise to spin up like in minutes and spin down in minutes, and there is no commitment, and your on-ramp to the cloud, as long as you are in the co-location or via service provider, or you want to be in the co-location, you can do it instantly. And if it is east to west, you even don't need to be in the co-location of the data center. Sitting at your home or in your office, you can spin up a virtual function and can on-ramp to the cloud service provider in 10 to 15 minutes. As simple as that. Now that kind of addresses all the 2-3 different issues that I just mentioned. Lastly, operational efficiency. Like no enterprise today, our customers or yourselves even would like to spend hours understanding what is Cisco, what is Juniper, what is Palo Alto, and so on and so forth, right? We would all want a simple user interface that tells me what is my Z end, that tells me what routes I need to import or export, that tells me what kind of basic security policies I need to have, what's the bandwidth requirement. Simple, plain. I don't need to know every vendor's CLI and their way of operations, right? Now that's what made easy via completely API-driven orchestration, right? And that's what we employ, and Equinix has it, and I'm sure a lot of other providers are in the process of enabling this in the data centers. Now that kind of very simply, we try to address the multi-cloud networking challenges that we have been seeing and we see today even in a lot of our enterprises. For example, there was an enterprise who actually needed a transient connection, direct connect to OCI and AWS because of traffic migration for about 100 petabytes of data. Now imagine we don't have this set of solutions. What would take that enterprise to have this data transferred from one CSP to another without burning their entire pocket, their entire budget of the year, right? So with this, I kind of conclude, and I open the floor for any questions. No questions? All right. Thanks, Saurabh.
Thank you, Mr. Nihat, for those insights into how to optimize multi-cloud networking challenges. Next topic is around similar lines for service provider, how to tweak the performance. I would invite Mr. Priyaranjan Khan from Web Surfer Communication Private Limited. The topic kind of touches upon what are the major challenges faced by service providers, and I'm sure Mr. Priya will cover how the old and the newer technologies of IGP, BGP, routes, routing, etc. are used to overcome them. Let's give it a round of applause to Mr. Priyaranjan.
Hi, good afternoon everyone. My name is Priyaranjan Karna. I have been working in service provider network since last 9 years, and currently I'm working with an ISP in Nepal, Wave Surfer Communications. So I'm going to present some performance tweaks about some routing protocols that helps ease the network and performance, increase the performance of network. So I'll be talking about 7 challenges and 7 protocols that help in mitigating those challenges. We'll go one by one. So the first challenge, I'll be talking about the IGPs that service providers use as an underlay, generally the OSPF and ISIS. So generally OSPF and ISIS were not designed to install a backup path, if any. So if the primary path fails, it results in packet forwarding delay in packet forwarding, as it triggers recomputing to the backup path. So the service guarantees the service that we guarantee to our end user customers for 50 milliseconds, that cannot be achieved with default behavior of IGP. So we can use LFA loop-free alternative as a tweak to the IGPs to pre-compute a backup path, if any, and that needs to be loop-free and pre-calculated to insert. And if in case of a failure happens, before the packet forwarding engine gets a recompute, the IGP starts forwarding the traffic. So LFA can be configured in 2 ways. One we can do with per prefix LFA, and one we can do per link. So per prefix in per prefix LFA, all the prefixes that are using the same next hop and same link will be transferred to the same next hop in case of a failure. And this can be a disadvantage in service provider network, as you put a lot of traffic burden to the same link in case of a failure. So if you see, there are 2 ways to configure it. One is you can trigger your IGP to configure one is fast reroute per link, and the other is fast reroute per prefix. So you can use any of it as per your convenience. Generally, service providers prefer using the fast reroute per link, as when a primary link goes down, all of the traffic is migrated to move to the next link. So if you see this output, before enabling LFA, a destination 172.20.1 has only 1 link inserted in the routing table, and when this particular link fails, it should recompute the
backup path, it should run the SPF again, which is going to take some time. But after enabling LFA, you can see that the destination is all protected with a backup path, which is 10Z0001. And if in case the primary link fails, the traffic is immediately switched to the backup path, which is already pre-computed. So with this, we can achieve our upper layer protocols like MPLS 50 milliseconds of convergence time. The other challenge that we face in service provider network is the level allocation that LDP does, the IGP does. So let's assume if you have, let's say, 100 of MPLS boxes, and each box having at least 2 links, primary and secondary links. So you are going to generate 300 labels, including the loopback. But actually, not all 300 labels are required. Only 100 of them are required because the traffic is never destinated to the link. They are always destinated to the loopback addresses. So 200 labels, extra labels are actually never used. So we can cut them down, and you can ask LDP, you can configure LDP to configure, generate labels only for host routes or the prefixes that you intend for. If you do that in 100 MPLS boxes, your label assignment is only going to happen for 100 prefixes, that are the /32 prefixes. And with that, you can add 200 more MPLS boxes, or the MPLS boxes which have a label constraints can scale with this technique. So if you see on my on your left-hand side, the default label allocation is assigning label for all those IGP routes which are not actually needed. And with the filter, you can see only /32 routes are being assigned with a label, which helps in scaling the MPLS network. Moving forward, URPF. So the default behavior of unicast routing does not ever check the source of the packet. So it is easy for the attackers to spoof the source address and send packet in the network that would otherwise have been dropped by the firewall or some ACLs. And also it causes suboptimal routing because the edge routers which do not have the route to the source might have dropped the packet in transit rather than forwarding it to the other core devices in your network and adding an routing compute. So in order to prevent this and to drop packets at the edge of the network which do not have the route to source of the packet, you can use URPF at your edge devices, which can again be configured in one of 2 ways. One is URPF strict mode and one is loose mode. The strict mode checks for 2 things: that if I have the route to the source of the packet or not, and if I'm using the same interface to reach back the source on which the packet was received. If any of the condition is violated, the packet is dropped at the router which URPF is configured on. And the other way is loose mode, which only checks if it has the route to the source back or not. So generally, service provider prefer to configure loose mode because they do not have symmetric traffic flows in their network. And this can also prevent spoofing attack, source spoofing attack. Moving forward, the next topic we have is BGP table map. So generally, route reflectors that service providers host are only used for data planes used for control planes rather than data planes. So installing the routes that the route reflectors are reflecting in the routing table or RIV or FIB is going to consume the routing resources of your routers. Rather than, what we can do is we can use BGP table map to filter the routes that are going to be installed in the routing table. And this helps your route reflector compute enhancement. So, so this is a scenario where I have demonstrated a route reflector and 2 route reflector clients. So the route reflector is reflecting prefixes, and I have used a filter and as ACL to only permit odd routes. And we can apply this policy to the BGP address family. And if you see the output, the route reflector is reflecting all the routes to its RR clients, but not installing them in the routing table. So the RIB should not be having all the routes. And by this, you can also ensure that the route reflector is not going to be in your data plane and only has to be in your control plane. BGP route aggregation. This is something that is always discussed in every conferences and every technical sessions, that the route that we advertise in internet, the routing table is growing day by day, and the resources that is required for the routers to install all the all the prefixes is quite high. So, and it also deaggregation of prefixes is also hampering or impacting the routing stability of the internet. For this, I have a scenario here where AS1 is by default, let's say, advertising 8 prefixes to its eBGP pairs AS2 and 3. Now, if the first thing is that you are going to have numerous routing entries on the AS routers, the first thing. The second thing is, if in case, let's say, any customer, any prefix of the /24 of AS1 goes down, it has to send a prefix withdraw to 2 and 3, which temporarily is going to impact the routing table of AS2, 3, and their adjacent ASNs. And if in case, let's say, the same prefix, the customer comes online and gets injected to the IBGP of AS1, it is again going to advertise the prefixes to 2 and 3. However, the customer might not have the internet accessibility immediately because of routing propagation delays. Instead, if the customer or AS1 aggregates those prefixes to 1/21 and advertise to its adjacent pairs, AS2 and 3 in this case, the size of routing table is also going to decrease. You will have less number of routes, and it will help in quicker routing table lookups. As well, if in case in the same scenario, if any of those /24 prefix goes down, or the customer network goes down, it is not going to send an withdrawal message to its upstream messages. And it will upstream ASNs, and it will help in routing stability of the routing table for the AS2, 3, 4, 5, and so on. Next is 6BPE and 6P. So most of the service providers are, nowadays we are struggling for delivering IPv6 services to our end user customers. Where our service provider core were only designed for IPv4 earlier. To deliver the IPv6 services, either we'll have to move to dual stack, where we'll have to enable all the MPLS boxes with IPv6, for which we'll require an IGP that supports IPv4 and v6 both, and then MPBGP and obviously LDP for IPv6, which might be a time taking, and resource availability might be a constraint. To overcome this, we can use 6PE and 6BP, where not all the MPLS boxes needs to be IPv6 aware. Only the provider edge routers, which are delivering the customer services, can be enabled with dual stack, and the rest of the core, the P routers, can switch the MPLS packets on the basis of labels. So this is this is going to exploit the fact that as long as packets somehow can be forwarded along an LSP from provider edges to other provider edges, the P routers do not care about anything but only the transport label. So this is a beauty of BGP and MPLS, where not all the MPLS routers needs to be configured with V6, IPv6. So 6PE is where the MPLS is connected, so the customer is connected to the IPv6 unicast routing table rather than VRF. We only need to establish a V6 adjacency with the customer at the provider edge, and pairing, and we can pair the provider edges under the address family IPv6 with a command send label, which is going to do is send the NLRIs with the MPLS label for IPv6 routes. So what happens is we'll be using the same IPv4 addresses for label assignment rather than having LDP to exchange labels for your IPv6 routes. So if you see here, I have used a route reflector to demonstrate the scenario where two provider edges, P1 and P3, are connecting the customer C5 and C6, with which we have enabled the IPv6, whereas the pairing between the route reflectors and provider edges using IPv4 addresses, but under the address family IPv6. And if you see the output, the next hop for the IPv6 routes is embedded with an IPv6 address for the IPv4. So IPv4 address is embedded with an IPv6, and the label for the label assignment is used same as for the IPv4 routes of the provider edge. And if you see the output of customer edge to customer edge communication, you can see that in label 2 it is using the transport label, and the IP address that we are using is an IPv4 address with an IPv6 embedded on top of it. 6BP is also the same. The only difference is going to be is that the customer now is under the address family IPv6 and under a VRF, L3 VPN service. It also uses the same technique, an IPv6. The next hop is going to be an IPv4 address embedded with an IPv6 is prepended on top. Same setup, whereas the pairing between the provider edges is going to be under address family BPN v6. And if you see the output, the IPv6 prefix is advertised to the other provider edge using the IPv4 as the next hop embedded with an IPv6. And the communication between the customer edges is again going to use the same IPv4 address. Lastly, Anycast RP for multicast. So in multicast, we use RP for source and source. We use RPs for source, registrations, join, and prunes. So if let's say you only have one RP in your network, and if it fails, your new joins, prunes, and source registrations is not going to happen until the RP comes back online. So what we can do is we can have multiple RPs in our network using the same Anycast IP, same as we do for the DNSs. So it is going to use MSDP as the protocol. So if a source registers itself to one of the RP, multiple RPs are going to use the same IP, and it can use the IGP to register itself to the nearest RP, and the RPs can sync the source registration, the prune, and joins using the MSDP protocol. So if in case one of the RP fails, the other RP has that information, or another RP is going to solve for the join, prune, and source registration. If you see here, the two RPs, RP1 and RP2, is using the same loopback, the same IP, which is advertised through IGP, and the source and receivers are going to register themselves to the nearest RP on the basis of IGP routing table. This was from my side. Any questions?
Hello. So my question is on the on your first slide where you was showing LFA.
Yeah.
So can you let me know if we can use LFA in our OSPF infra as well?
Yes. So generally service providers do enable LFA so that if in case there is an alternate path, it is pre-computed and installed in the routing table. So if the existing path goes down, the backup path can immediately be prompted for packet forwarding. So we do use that with OSPF and ISS as an underlay. Because
So for LFA, shown the timer of 50 millisecond. But nowadays, still we are using BFD in our infra as well, where timer is less than 50 millisecond. So why, what exactly the difference, or why we need to use LFA instead of this BFD?
BFD. So see, BFD. If in case the link failure is direct, it is going to trigger it anyway, right? But BFD is only going to signal the routing protocol that there is a failure that has occurred, right? But to install a new path, they have to run the SPF, which is going to take time. BFD is only going to signal your IGP that a failure has happened. But IGPs, OSPF, and ISS, they do not pre-compute a backup path and keep it already in place like EIGRP does. So BFD is going to signal your IGP, but the recomputation still has to be done.
Recomputation can be done via that BFD as well.
Backup path, the other path. No,
I believe LFA is just installing a backup route.
Yes.
So earlier, we don't have any backup route. So I think it is just addition where we are able to see what is our backup route. So as such, the requirement point of view or the backup point of view, the convergence point of view, I don't think it is solving our purpose.
So see, in ISP network side, you have multiple links. All of your protocols that you are using rely on the IGP, right? So if you have multiple links from a, let's say, MPLS box, and if the link goes down, BFD is obviously going to signal in case of indirect failures to your IGP, because IGP cannot detect the failure as quick the BFD does, right? So it is going to signal your IGP that a failure has happened. But for the IGP to take the next path, it has to run the SPF, which is again going to take some time.
Okay.
So BFD and LFA can run in conjunction.
So, okay. So my second question is on this Anycast RP.
Okay.
So, I'm not able to understand as per your slide. Are you giving some solution to overcome that RP or?
Okay. So in multicast, the source who is serving the multicast feed, the receivers who are wanting to get the multicast feeds, right? They register to a common point known as RP. So if you have, let's say, if you have a big network, all the source and the registration, if an RP fails, the registration and source interest, the receiver's interest are not going to be registered. So what you can do is you can have multiple RPs in your network with the same IP, same as like Anycast GNS works. So you can have
that actually we are,
yes.
This
So
is actually the purpose, or we are building like this way only. So
so you can have multiple RPs with the same IP, and the registration can be done to the nearest RP.
Nearest
Both-
RP, right.
Yeah, and both the RPs can sync their source registrations and receivers interest through a protocol MSDP. So if in case registration happened to one of the nearest RP, the other is also informed about it.
okay. So last question regards to your IPv6.
Yeah.
So in IPv6, if we are running this OSPF version 3.
Yeah.
Okay. So in OSPF version 3, as if I don't want any authentication, so
Don't want what?
any IPsec authentication, because OSPF version 3 is not supporting other this MD5 or plain text authentication like OSPF version 2. So if you have any idea, is there any way instead of IPsec, anything other we can use? Maybe it's not as per your slide, but just want some suggestion on it if you have any idea.
So,
Because it was in your slide relates to that authentication.
So for ISPs, right, there we have more than 100 of MPLS boxes which were earlier designed for only supporting IPv4, right? Now enabling IPv6 on all the boxes running a different protocol stack, maybe OSPF v3 or ISIS, is a challenge, because of which what we do is to deliver services to our end customers. We only enable IPv6 at the provider edges. Not all the boxes are IPv6 aware. So you can use 6P and 6BP for that. So you can only enable dual stack on the boxes where the customer is connected, and the other end of the other end of the network where the customer hand of port is. So with that, you do not have to enable IPv6 on all of your MPLS boxes. They can just label switch on the basis of.
Yeah, MPLS is it's in a service provider. That's okay. Okay, thank you very much. And it was quite good session. Thank you very much.
Anything else? Anyone else?
Hello? Yeah. So I guess we have to update our first slide to use BFD along with LFA. That will solve the purpose. That was the same question he was asking, right? So we need to use BFD along with LFA.
So see, if your ISP network, the MPLS's boxes have direct connectivity, and if the direct link fails, that is going to trigger quick. But let's say if you have a switch in between, the other end is not reachable.
Every protocol has timers, hello timers configured.
The timers are not in milliseconds, right? But the MPLS service that we deliver, we guarantee our customers.
Exactly, that is why the BFD is required.
Yeah,
those timers are like 10 seconds.
Yeah, I get your point. BFD is only going to trigger your IGP that the failure has happened, right? But the IGP again needs to recompute the backup path.
That is what I'm saying. Along with LFA, BFD has to be.
Yeah, BFD and LFA can be run in conjunction. It will give a better output. Any more questions? Thank you, Ben. Thank you.
Thank you so much, Mr. Ranjan, for that presentation. Can we again give a big round of applause? All right, so before moving forward, we have, ladies and gentlemen, I believe we have already mentioned before that conferences like these, events like these, are not possible without the overwhelming support of our sponsors. And we'd like to take a moment to appreciate all our sponsors. And for the same, I'd like to invite on stage Mr. Rupesh Shrestha, SANOG Chair. Can we please welcome him with a round of applause once again?
Thank you, Priya. So we're just stealing a few minutes away from this program to felicitate our sponsors. I'll just call out all the names of the sponsors, and we can, all of you can come over on the stage, and we can just one by one we can distribute our token of love. If somebody from CFI can come up on the stage, I'll just read out a name. Please come to the stage. CFI, Nixie, Epinic. Epinic. Dickex, Equinix, Amazon, OpenGear, WebWorks, ExtremeIX, Control S, Google, Shan Technologies, and Tata Communications. I hope this stage is strong enough to hold all of us. Microscan, AsiaNet Fiber, Yota, Benox, Digital Connection, Team Simbru, ST Telemedia, Velimento, Catchpoint, We still have more? It's still strong. BBIX Japan, STPI, Netflix, Epinic Foundation, Flex Optics, Internet Society Foundation. Along with this, I would also like to thank our community sponsors, ICANN, IFON, ISOC Delhi chapter, CCAOI, Satellite Netcom, and also a big thanks to Ministry of Communication, Department of Telecommunication, Ministry of Electronics and IT, and special thanks to iSpy for all the support, and INNOG for hosting this event, and also Apricot for endorsing our event. So thank you all. So we'll go ahead with the sponsors' felicitation. First, let me request Praveen sir to come up on the stage and help felicitate few felicitations. Sifi, thank you, Sifi, for your support, and thank you all the sponsors. Nixie. Epinic. We will take a group photo also. We'll take a group photo later. बाद में group photo लेंगे. Dickix. Quinix. Thank you, Praveen sir. May I request Parar sir to come up on the stage? Next, I'd like to request Amazon, AWS, Amazon. No? I think he's already left. Open Gear. WaveWorks. Extreme IX. Let me see, Ronak. Ronak was here. Yeah, there were so many people. Control S. Google. Oops, wow, good catch, sir. Were you a goalkeeper earlier? Next. Thank you, Parar sir. I'll request Pankaj sir to come up on the stage. Thank you, Parar sir. You are late. So I took your gift. So thank you, Extreme IX, for all the support. Ishan Technologies. Tata Communications. Tata Communications. Thank you, Pankaj sir. Next, I would like to request Matt to come up on the stage. Did I say microscan? Microscan? Yes, microscan. Thank you, microscan. The internet connection is from microscan, right? AsiaNet fiber. Yota. Venox. Digital connection. Thank you, Matt. Thank you, Matt. I'd like to request Masan to come up on the stage, please. Team Simru. Kimru, sorry. Kimru. ST Telemedia. Velimento Technologies. Catchpoint. Thank you, Masan. Next, I'd like to request Rajesh Panwala, sir, to come up on the stage, please. BBIX, Japan. STPI. Epinic Foundation. Flex Optics. Internet Society Foundation. I'm not sure if anybody from Internet Society is there. Anybody from Internet Society or Internet Society Foundation? Okay. Thank you, Rai sir. Next, we'll just take a picture. Did I miss anybody? Oh, Netflix. Natasha. Netflix. Hassan, can you come up? I'll give you. Thank you. I think that completes our appreciation for all the sponsors, without whom this event would not have been possible. Thank you very much. And I'm sure local host INNOG had arranged the special token of appreciation, a very expensive one with the sponsorship amount. Thank you, everyone. Thank you, everybody. We'll just have a quick break for a tea break, and then we'll come back for our next session, maybe in 10 minutes' time. Thank you. We'll continue again in 10 minutes' time. Please don't go away. We have a few other interesting presentations.
And the last session, the segment for this day. So I would request everyone to please settle down. We have our session chair and our speakers waiting for their presentations. I would urge everyone in the aisle area to please take your seats. A quick request to all our members of the audience, people standing right here in the middle in the aisle area, to please take your seats. We're about to begin with our next presentation. A quick request to all our members of the audience, once again, to please take your seats. We're about to begin with our presentation. We have speakers waiting right here. We begin in the next 1 minute. All right, and it's time we resume with our next very important and crucial technical presentation coming right your way. And to chair this session, may I please invite Mr. Rahul Makhija to join us on stage and invite our fellow speakers to take the presentations forward. Thank you.
Good evening, everybody. Up for an exciting technical presentation next. Next up, we have Anurag Bhatia, who's a network researcher at Hurricane Electric. They're an ISP doing IP transit in 50+ locations across the globe. Besides that, he's also an instructor, by the way, for DNS workshop at this event only. He'll be presenting his research on distributed latency monitoring. Anurag, please.
Hi, good evening, everyone. My name is Anurag, as Rahul introduced. Thanks, Rahul. I'll be talking about distributed latency monitoring. So I'll be covering about the problem which many of the network operators have on checking latency at a large scale from your network towards other networks, from within your networks, as well as towards different locations on the internet. So various tooling aspects of it and some of the challenges I'm suggesting to solve with the method I'm proposing here. So we start with the idea of smoke ping alternatives. For those who may not know in the audience, smoke ping is a well-known tool for latency monitoring. It used to have some basic options like ICMP checks and DNS probes for measuring DNS latency, HTTP, and so on. It had quick configuration, so one can just simply write a basic endpoint, define basic endpoint, and to start monitoring latency. Now, some of the challenges which affect smoke ping essentially are, it's hard to scale up. So if someone is running a smoke ping right now at one instance, it won't really scale up to thousands of endpoints. And if you are distributed, if say you are operating in the Indian context in Mumbai, in Chennai, in Bangalore, Hyderabad, it's hard because now you have to run different disconnected smoke ping instances who are not really speaking to each other, and now you have to look for different graphs at the same time. So for instance, take a simple set of 5 locations, 50 graphs. To monitor latency, you literally have to scroll through 250 graphs, which is not really feasible for a NOC part. And it has limited alerting support. It supports old school email, but that's about it. It does not really support out of box for modern push-based mechanisms. So I started looking for alternate. Now, overall idea remains the same. You watch out for latency from various endpoints. Should not be single endpoint, and it should be from many sources to many destinations, wherever you can get access to. And it should be easier to have a single tool to monitor latency as well as servers, network infrastructure. If you have a tool only for latency, then you have to fit it into your system in terms of getting alerts, in terms of having one more dashboard just to manage that. So this takes me to Prometheus. That's an open source tool one can make use of at this point of time for large scale latency monitoring. How many of you in the audience already use Prometheus? Can you please raise hand? Okay, great. So the overall idea of Prometheus is quite simple. It's just a time series database. It's simply storing various metrics. So you are essentially collecting metrics and storing that in a database, and it is making those available with the API request. So there is a very good ecosystem around the Prometheus with good web interfaces, with good exporters which are putting the data. By default, it works on a pull model. So you run various exporters at different location. You pull those metrics in the time series database, and then you interpret those metrics. I'll come on to some of the simpler examples soon. So it can store any sort of metrics. So it can literally store like a CPU or a memory. Memory usage at a given point of time. It can also store latency as part of that, or it can also store HTTP request times as part of that. So any metrics can just go in. It's simply a database, nothing more than that. And it speaks via various agents using regular HTTP methods. So one can make it speak to over HTTP endpoints or public internet with TLS, or one can even just do it over VPN. The design part, so essentially, let me turn on the laser. So essentially you have something like, you have exporters running in your infrastructure. These exporters can be depending on the use case. You may have exporter for, say for a server, you may have exporter for just pulling server related metrics. For a router or a switch, you may have exporter for pulling in the interface data and so on. It also supports push method using a push gateway, although it's not very common to use that. It would store that in time series database, and then to ultimately analyze the data, you can make use of popular open source tool called Grafana, and it integrates very well with Grafana for putting out these charts. So I'll show you some example of charts as we proceed. Now, the core idea of Prometheus is that everything is metrics. Whatever can go in metrics, it can store that and it can interpret that. You can have different set of rules based on those metrics. If there's a mismatch, it can give you alerts based on latency jumps or whatever. So the overall idea stays that whatever metrics can be interpreted, they can be graphed. Essentially, it is possible to look at average, because when you start collecting these metrics on regular basis, let's say once in every 10 seconds or once in every minute, you can collect it at that scale, but while you're looking at the data, you can average it out. You can say, I don't really want to see latency jumps if it was for less than, say, 5 minutes. You can just average out that data if you want to. You can attach various labels. So for instance, if I'm collecting metrics for Mumbai, I can attach labels saying city name is Mumbai, country is India, region is Asia. So any sort of metrics you can attach which makes logic. I also tend to attach metrics based on the destination endpoint. So I can say ISPs in India with a metric, and now everything which is tagged with that can be pulled with that specific label later. It supports alerting via Alert Manager against predefined rules. So here's an example of pulling of metrics. I'm not sure if the question is quite clear, but essentially I'm querying one of the endpoints on my server in Europe for the metrics of the server. It just gives me out the metrics for the server's current usage in terms of memory and other things. Um, now, Prometheus in itself is quite an advanced tool for large-scale monitoring. We are looking at only one aspect of it, which is for the latency monitoring. For latency monitoring, there's a well-known exporter called Black Box Exporter. Black Box Exporter essentially supports open source probing. So you use Prometheus with Black Box Exporter to make use of large-scale latency monitoring. If you want to do other things, you look for other exporters. If you want for, say, some specific vendor device, you look for some specific vendor's exporter, essentially. It can be probed with HTTP endpoints, just like any other exporter, and it supports monitoring, say, of HTTP, HTTPS, DNS, TCP, etc. Most of protocols, as you would expect, which you want to monitor in production. It is written in Go, so it's a single Go binary, so it can be simply added on your server and executed, or you can also get Docker container for that if you prefer that way. Here's an example. I'm essentially here querying for our domain he.net for latency to this server in Mumbai. Now, this is giving me the output essentially when I query this exporter. So the RTT part here is essentially giving me the time. So this is 0.26 in seconds. So 260 milliseconds is the response. Now, this is essentially just a metric with a specific label attached to it, which is phase RTT going in the database. Right now, it's a manual call, but when you do it from Prometheus, you just put it in the time series database. In the same way, let's say here's a HTTP query for something like SANOG.org. Now, instead of ICMP, I'm looking for the HTTP latency. So you see something like total probe time. You also see an overall breakout of how long it took to connect, how long it took on the TLS process, how long it took on the transfer process, and so on. So it gives you quite detailed metrics as an output when you try connecting. So here's the example of making use of these exporters in Prometheus. So I've put out some of the examples I use for my own internet service provider. So this is the provider I use at home. So I monitor their WAN IP for fun. Then you can have it written in this manner where it's one endpoint with multiple labels, or you can have one single target all attached with a common label. So for instance, these are some of the servers for fun I'm monitoring for latency from my home. So it's a bunch of speed test servers essentially with labels like public or region label like India. Now I can pull out this data just based on matching of these labels as I need to when looking for this data in bulk. I'm not sure if it's that readable, but essentially this is just querying for data for the ICMP for the specific region of Hong Kong as an output. I could query in the same way for, say, something like India or even a city like Mumbai for the data which exists. I think I can skip this slide, it's not clear either. So this again is a query example from within Prometheus. You can generate graphs within Prometheus, although these are mostly for troubleshooting and quick rendering parts. Usually you would not use it in production. For production, it makes sense to use it with Grafana. So Grafana can easily be plotted. So whatever you can query within Prometheus, you can easily plot it within Grafana. So here's an example of Grafana query, and I'm glad it's actually more clear to read. So this one is a query. In the bottom, you'll see the query. So it is saying average. This is doing the averaging over time for the ICMP with this specific source, which is my Mumbai server for the RTT phase for the region India for specific speed test. In this instance, it's the Mumbai speed test server for Airtel as an example. Now, I am looking at this data for last, I think this is what? It's for entire month. So everything pretty good, and then just sudden spike. Now, for these sort of cases, I can actually generate alert. Here's another example case. Now, this time it's querying for the speed test server Dell's, the Delhi speed test server for Airtel. Again, the same query, same source. Lot more spikes, giving you idea that probably my transport or my transit player reaching it is getting some interesting congestion at times. Here's an example of another query, essentially for entire region Europe from the same server. And this time, this is a special graph because this graph is not showing a single graph, but it's showing you all the graphs in between. So I got a bunch of random endpoints for which I'm monitoring for fun, and now it is showing me all of them together. And if I want to see a single graph, I can just click on it in the Grafana interface. It will just sort that out for me and will show only that specific graph. So it's quite powerful that way. So now you're not looking for essentially 250 graphs, you can have essentially 250 graphs all combined within a single graph if that suits your use case. Here's another more complicated example case. This is from the exporter running at my home on one of the Intel NUCs, and these are all the 13 root DNS servers. So, and I think this is for entire 1 month. So 1 month data towards 13 endpoints from one single source. Again, making it much more easier to read the long-term data on how the latency overall is going. Now, whatever here can be queried can be used to give alerts. So one can have really useful and powerful cases here for giving alerts. So for instance, here's an alert saying, if the ICMP latency to one of the domains I used as an example earlier for different NOG, HKNOG, if it goes above 120 milliseconds, just throw me an alert. And I can also do an averaging here. I can say, if the latency increases above 120 milliseconds, where the average is of last 4 hours, then only give me an alert. I don't want alert for just individual spikes. So that is definitely possible. Just another example case, Hong Kong to Germany, if it goes over 300 milliseconds. So it says the same metric essentially greater than 0.3. Using 0.3 here because the time here is in seconds as opposed to milliseconds. So it will throw something like this on an email, or it supports various other channels like Slack or various other push mechanisms. So you can get similar alerts on other tools. Coming on the part of scaling up, one can run number of endpoints. So ideally, if you have networks spread across different cities or different POPs, you can run endpoints at all these locations. Endpoints are super lightweight, so one can run them on really low end compute. You don't need a massive compute. You can export all that data centrally, and that's where you keep the data. That's where you maintain resiliency. You don't necessarily need high-end compute at all your POPs just for this probing aspect. One could even start with something like Raspberry Pi. It would do quite well for this sort of thing, although it may have issues in terms of power redundancy maybe. One can run multiple Prometheus server if that's the use case you end up in hitting. So one can essentially aggregate the view as well. You can have one server for North India, one server for South India, and get an aggregated, consolidated view if that suits you. One can also support the metrics essentially on the S3 endpoints, and it will give you an infinite scalability. And one can run it one can run essentially independent Prometheus instances with high availability on the alert manager to give you deduplication if that's a use case you want. So it can go all the way from super simple single server deployment to extremely highly available redundant deployment if one needs that. And there is support for things like Thanos, Cortex, Grafana Mimir, etc. Most of these tools allow you to have various other aspects like the consolidation, like this federation of instances, like having S3 as an endpoint for storage, etc. Now, how this all fits in, if you're wondering, we were looking at smoke ping graphs earlier, where we are here now. So let's look at this now. These were the smoke ping graphs earlier, individual smoke ping graphs. Now, all this can be combined literally in like these two graphs. And if one needs to focus on a single graph, just click in there. So it gives you this sort of easy availability of dashboards for looking at large-scale latency metrics. Now, until this part, it was all about latency monitoring. You might be wondering, what about the distributed part? How do you get distributed latency monitoring? You can run these probes within your network, but what about things with outside network? This is where RIPE Atlas comes in. So you might have seen my friend Leah from RIPE NCC, her talk on RIPE Atlas earlier. Essentially, it's a large-scale distributed project where you put RIPE Atlas probes in your network, and as a part of that, it's a barter system. You get access to thousands and thousands of other probes from the other networks, and there are RIPE Atlas related exporters available. So one can run a query, essentially, one can run a measurement on RIPE Atlas and use an exporter and get that data from that exporter and just pass it along. So for instance, for fun, I monitor latency from various Starlink probes towards my home and plot that as on regular basis. So here's an sample config for that. So I'm using this exporter on this specific server. I have provided it with a bunch of measurements. So I'm essentially measuring from Starlink towards my home, towards a bunch of my servers at different location. And here's how graph look like. And all this metrics is going to stay there as long as I want to. If I run out of storage, it is horizontally scalable. I can always throw some of these metrics off to to S3 endpoints and average data out to essentially reduce the storage. So this is where the distributed part comes up. Another important point to add here is specific to Google. So a lot of people look out for their latency with Google, and that's important because Google, as of now, is majority of traffic. At least on the Indian profile, it is somewhere like 40 to 60% traffic. So because black box exporter is stateless, one can run it as a stateless container on some of these platforms, including Google Cloud Run. So I have a black box exporter running it on Cloud Run, as opposed to say running it on a static virtual machine, which would cost you much more. So it would simply trigger the container whenever I request for it, and it can give me latency alerts. So here's a sample config. So a sample output. This is from Google Cloud region in Delhi towards bunch of friendly operators, and this is showing me how the latency is varying towards them. Here's the sample config about the alert manager. So my good friend Mr. Prashant Chadda from Dell DSL, earlier he was having this problem where suddenly Google's latency would increase to his network, and I ended up in putting an alert specifically for him in my system. So I'm essentially monitoring latency from GCP Dell, essentially by running a black box exporter in Google Cloud region as a stateless container. And I'm monitoring this latency specifically towards him, and if it goes above 10 millisecond, I get an alert, and then I speak to him about it, and essentially say, hey, I know that your latency has increased. Go and speak to Google about it. So it is quite powerful with this kind of tooling. Summary, metrics is becoming standard of tooling, so not just about for latency part. If you are not using metrics already, please do explore that. It's a good idea. If you are running servers, it would be a good idea to explore a metrics-based monitoring system, as many of the hyperscalers do. And systems like Prometheus, these do scale well. There is definitely a slight learning curve, because now you're not looking at a single instance installation. You're looking at this distributed part of having something like Prometheus centrally, then bunch of exporters, and connecting those exporters on a encrypted layer. So there is definitely some learning curve, but it is quite useful. And many of these components can be used or can be skipped depending on the use case. If your goal is to just monitor latency from single location towards bunch of locations, you can easily do it with single installation. While if you are large, you can easily do this large-scale federation and scale it up as you like. And labels play a very important part here, because labels are essentially grouping, and you can do search or alert, any sort of those things with this logical grouping between locations or destination endpoints, etc. All the examples and tools I showed you here are open source, except the specific Google Cloud example. The package use, of course, stays as the open source, but then Google Cloud itself is a commercial product. So other than that, all the examples here are purely open source. So I've linked across all of them. The second last one you may want to look if you want to scale it up to great levels. Else you may not really need to touch them, and the default installation would just work fine. That's about it. Any questions? Yes. Can we get microphone to Swapnil? State your name and affiliation.
So this is Swapnil Shrestha. So my question is, the Atlas exporter that you're using is the Atlas _ exporter. Is that the same one, or is it a different one?
Whether it's underscore or dash, I need to find that out.
So the Atlas measurements that you referred to in the previous slides, that is from a static measurement, right?
Yes. Here's the exporter. Yeah.
So that's from a static measurement, right?
Yes.
What if one wants to? It's not a one-off measurement, and you would like to, continuously run that measurement and still plot it.
It is not a static one. It is, the measurement is running repetitively. So this is not a one-off measurement. This has been defined without an end time. It will run continuously, and every time exporter will run, it will get that data out from RIPE's infrastructure to my time series database, so that it stays locally. So it is a continuous one.
So that uses the streaming API, if I'm not mistaken?
No, I think it uses their REST API to get the data from their database to mine, and then it plots based on that. it's not using streaming API, but I think that's a good point. We can explore something like this specifically with RIPE on the streaming API part.
Because the Atlas underscore exporter, which I referred to earlier, has something called as a streaming API.
Oh, okay.
Which basically continuously polls the RIPE Atlas infrastructure.
Okay.
And fetches the data, and then you would have that data to plot it on.
Okay. It might be that a specific configuration of it to use streaming API. In this scenario, it is essentially coming up whenever Prometheus polls it, and it gets the data at that given point of time. So I do not poll it like every minute. For most of these long-term measurement, I do it like once in an hour for something like this. For my own servers and internal part, I do it more often, like within half a minute. But this, it would just poll RIPE's infrastructure once in an hour or so. In this case, it is even 6 hours as a sample example.
Not wanting to put you on a spot, but it would be a cool project to basically plot latency to root servers in India.
Okay. Already doing that from a bunch of endpoints, but not necessarily showing the data out here. Just ugly graphs. Thanks. Any other question? I think it's done. You can proceed. Thank you.
Thanks, Anurag, for such an interesting presentation. Next up, we have a young and dynamic student, Molya. She is currently pursuing her PhD in Department of Computer Science and Engineering and at NITK, National Institute of Technology, Karnataka. Her research focuses on the domain name system, particularly on encrypted and blockchain DNS. She'll be sharing her analysis on performance of DOT, DOH, and DOQ across internet-connected DNS resolvers. Molya. Have to wait for a minute or so. Yes. So there is a problem with the slides for Molya. Meanwhile, they fix this up. Let's welcome our next speaker. Swapnil? Where are you? Just a minute, man. I wasn't prepared to introduce him. Just give me a second, please. So I guess Swapnil needs no introduction, but still, Swapnil is the CEO at Shrestha, a DNS security and cyber threat intelligence company. He's a co-chair of DNS Abuse SIG at the Forum of Incident Response and Security Term, FIRST. As is the first licensed member India, he's also an APNIC community trainer. Please welcome Swapnil.
So thanks, Rahul. All right, so I was prepared to go last. Thankfully, that's not happening. So anyways, on to the meat of the topic pertaining to this presentation that I have. This is something that I gave at the DNS Community Day in Thailand, in Bangkok to be specific. And it's part of a research that we have been doing from a threat intelligence perspective. So the background is that. So I'll just lay the background first, then go on to the problem and the solution. So back in November 2022, we started observing a very peculiar phenomena pertaining to domain names registered under .lk, right? So .lk, as you already know, is the country code top-level domain for Sri Lanka. And just to give you a little background, it's a very regulated process of registration. So if anyone wants to register a domain name under .lk, one cannot just go to a registrar and search for an available domain name, make a payment using a credit card, and acquire a domain name. It's not as easy and simple as that. So the regulation is pertaining to the process in place wherein the registrant who wants to acquire a domain name has to provide documentation pertaining to citizenship, proof of citizenship, identity documentation. If it is a business, then the business entity documentation and so on. And when I was at LK-NOG, prior to sharing this research, while picking the brain, I was told that this has been done primarily from a security perspective to prevent the abuse of domain names under .lk. But actually, that hasn't stopped the threat actors from using something called as a domain shadowing attack, where legitimate domain names under .lk are abused for malicious purposes, right? And that's exactly where we actually started looking at this particular attack. So this is not just limiting to .lk. This has its implications on a lot of CCTLDs specifically, and there is a pattern why this occurs, right? So I'll just run you through, couple of examples as well. So just to give you a background in terms of what is a domain shadowing attack, it's basically threat actors gain control of a legitimate domain name, basically the control panel, the DNS control panel of a legitimate domain name, log in into the DNS control panel, create subdomain records which point to the attacker's infrastructure, right? So the main domain name is completely untouched. The victim in this case has no knowledge that this has happened, because when they go to their website, when they go access their namespace, everything is fine. But the subdomain records that have been created are, is basically an ignorance or a blind spot for a registrant unless and until the registrant logs in into the domain control panel or the DNS control panel and sees those records there, right? So this is, in a nutshell, what is a domain shadowing attack. So just to give you a representation, example.com, I'm following all the RFCs from a perspective of making sure technically my representations are also right. So example.com, login.example.com, cpanel.example.com, all legitimate records, and they're pointing to a particular AS and an IP address. The threat actor creates fish, in this case fish.example.com, bang.c2, whatever and whatnot, and points it to the threat actor's infrastructure, right? So if you think it from a threat actor's perspective, why domain shadowing is useful or why domain shadowing attack is appealing is because end of the day, the threat actors, even with stolen funds, have to spend that money, obtain stolen funds like credit cards and whatnot to register malicious domain names, which are purely malicious. But this makes a lot of sense from a threat actor perspective because they can leverage the reputation of a legitimate domain name, create these subdomain records, which are purely stealth unless and until somebody, uncovers them, and be under the radar, at the same time achieve the objective what they are trying to achieve, right? So one of the things in which this is simply can be detected is a very simple solution, but something which does not exist in a large scale across the industry is that if registrars basically have a mechanism to send an email or a notification to a registrant after every record that is created or modified this problem goes away, because then you are starting to, notify the registrant that something is changing in your namespace, something is changing in your parent zone. But that doesn't exist. So the way to, we started looking at, so after doing it for a couple of years, with all this data that we had, we started saying, how do we solve it, right? This is happening in such a large way. What are ways in which one can detect a domain shadowing attack, right? So one of the simple ways to do that is basically deviations from the parent zone. So if the domain name is pointing to a particular IP address or an autonomous system, you look for deviations, which is pointing to a different autonomous system or a different IP address. May not be necessarily malicious, because a legitimate user could potentially also create that, but at least you are detecting. There is a possibility or there is a visibility that is coming in the picture, right? Subdomains, as I said, subdomains pointing to a different ASN, subdomains pointing to a different country, right? So the ASN or that IP block belonging to a different country altogether. Like I have my personal domain name brainattic.in. If abc.brainattic.in starts pointing to a different country altogether or a different IP, that's a red flag, right? So that's also a possibility to detect it. And also subdomains or DNS records which are pointing to flagged or malicious threat actor infrastructure, right? So there are something called as these bulletproof hosting providers, which are basically operated by the cyber criminals themselves. So if a subdomain is pointing at that infrastructure which has already been flagged as malicious, that's again a valuable insight to call that the hypothesis to say that that is a domain shadowing attack that is happening. Now, before I come to the solution, why this is happening? So the simple reason why this is happening in a very large way across majority of CCTLDs is weak passwords, no two-factor authentication that is available. So brute force of DNS control panel, and in generic sense, a lot of, not trying to generalize, but people using the same password across multiple websites, and then one of them gets breached. Now the threat actor has access to login details which can be used for brute force, right? And again, as I said, no monitoring in place to notify the registrant that there is a change that is happening, right? So best practice is strong unique passwords across, enable two-factor authentication. There are a lot of registrars who do not even have two-factor authentication as an option, right? So in that case, the registrant is basically stuck with the registrar in that case. And the last one is obviously to monitor the DNS zone for any sort of changes that is happening inside the zone. But that's difficult to do, because most of the registrars do not provide an API, do not provide any mechanism to notify, right? So we built something for registrants. This is called a shadow finder. So if you go on that specific URL, anyone who is a registrant can register for free, can log in and add your domain name, and then it will start detecting. It will take some time to detect that, and I'll also talk about what is running behind the scenes or under the hood, so you'll understand technologically what we are doing, because it is not rocket science, but at the same time, it is something that gives visibility, right? So what Shadow Finder does, the web application, is basically it gives you the visibility into your subdomains or DNS records under your parent zone. So don't just limit yourself to thinking that this is only for domain shadowing. I can tell you, speaking to a lot of enterprises and organizations, they basically create these DNS records and have forgotten about it, and it is pointing to stale network infrastructure, and that's also a concern from a security standpoint. So this is also a tool which can possibly give you visibility into that as well. So under the hood, what Shadow Finder is doing is we run our own passive DNS telemetry network as well. So it uses passive DNS. It also uses subdomain. So passive DNS is going to be a passive method. Subdomain enumeration is going to be a active reconnaissance to basically potentially find out subdomain records under a parent zone. And then we also look at certificate transparency logs. So every time a TLS certificate is generated, entry for that goes in certificate transparency logs, which is open for the world to see. That's because there was a security incident wherein a CA, if I'm not mistaken, a CA was compromised. And then the CA world got together saying that we need to have a mechanism where every certificate that is allocated to anyone on the internet, to any service on the internet, needs to be logged. So that's certificate transparency logs, right? So at this point of time, so even if you go on that particular website, there might be some rough edges pertaining to it. So if you find any problems, feel free and reach out to me. But at this point, this is not 100% foolproof. It is, there are limitations to this as well, because this is not getting access to the zone, right? This is not getting access to the DNS control panel. Passive DNS always will have limitations. It may not cover everything, because that's the nature of the internet, right? And subdomain enumeration techniques also have their own set of limitations based on the algorithms. And as I said, this is a very early release, so there might be rough edges, when you access it. But anything you find pertaining to any issue or anything that you can, anything that you see which is a deviation on what it should not be doing, or it is doing incorrectly, feel free and reach out to me. So the other thing what we're also working on is enrichment with threat intelligence data. So I talked about already IP address which has been mapped as malicious, right? So that is something that we are also looking at. Possible usefulness of having reverse DNS data integrated into this, which might give more insight into what are some other infrastructure which is also being used from a reverse DNS perspective, and alert by email. So if we find some new record using these methods, then send an email to the registered email address in Shadow Finder that here is an additional record that we were able to detect. So this is what we have done so far. Happy to take any questions, any input, suggestions. Thank you, and thanks for having me.
Thank you, Swapnil. So let's welcome Maulya once again on the stage.
Good evening, everyone. I'm Maulya. I'm a PhD student studying in NITK Suratkal. Today I'm here with my friend Teesta and my supervisor Dr. Soumya Hegde to present one of the performance study that we carried out. So this is about the performance analysis of DOT, DO and DOC across the internet connected resolver. These are the things that I'm going to talk about today. So first we'll look into the, some brief introduction, and then I'll speak why we are doing this performance analysis of encrypted DNS protocols. Then we'll talk about two setups that we have done, and we'll also I'll also talk about the result and the key takeaways from my experiment. So we'll also look into the downside of the encrypted DNS protocol and also, talk about what is the future research scope of it. So yeah, DNS, domain name system. It's a protocol that basically translates the domain name to its IP address, right? So the servers that store the mapping of this mappings are called as DNS server. So the traditional DNS that is there, this is the current scenario of today, correct? So the traditional DNS that is there is basically transmitted in a plain text. So anyone can just run a packet capture and get to know what I'm exactly visiting. Yeah, this is kind of a privacy invasion, and then anyone can also intercept the messages and redirect it to any of the malicious sites that are available. In order to address this issue, DNS encrypted protocols or DNS over encryption came into the picture. Today we have 3 DNS over encryption or DNS encrypted protocol, that is DNS over TLS, DNS over HTTPS, and DNS over QUIC. So these are the 3 protocols that is standardized by IETF for now. So DNS over TLS is nothing but transmitting DNS message over an encrypted TLS connection. So first, between the client and the DNS resolver, there is a TCP handshake, and then there is a TLS handshake. So once the the encrypted channel is established, the DNS messages are transmitted. TCP 853 is the standard port for DNS over TLS, and then DNS over HTTPS came into the picture. So basically, DNS over HTTPS is nothing but transmitting the DNS message over HTTPS message. So the starting handshake part is similar to that of DNS over TLS, and then the DNS messages are embedded in the DNS over HTTPS. So the standard port for DNS over HTTPS is TCP 443, and also it is same as the normal web traffic. It is basically the TCP 443 port is shared by both the HTTPS traffic and the DNS over HTTPS traffic. Which makes it kind of pretty harder to classify them as DNS over HTTPS traffic and the web traffic. And then we have DNS over QUIC. So DNS over QUIC is nothing but transmitting the DNS message over a QUIC protocol. So QUIC is a protocol launched by Google. So it runs on the UDP, but it also uses the goodness of TCP. So TCP suffers from something called as head-of-line blocking, right? So QUIC resolves the issue of head-of-line blocking. So why are we doing this performance analysis exactly? So in order to get to know some of the bottlenecks, if there are any, in this encrypted DNS protocol, and if needed, we could also propose some further optimization that is needed. And one more thing is we can get to know which protocol to use based on our requirement. And also what are the metrics that we are using for our study. So there are 3 metrics that we are using: handshake time, response time, and then there is the total time that is taken for a DNS transaction. So yeah, handshake time is nothing but the time that a client takes to establish a connection with resolver. And it is crucial because, in the normal DNS, the standard DNS that runs over UDP, this particular metric is not there. So we can, by analyzing this metric, we can actually understand the overhead that is there basically on the DNS transaction. And then we have total time and the response time, which is proportional to the user experience. So yeah, we have actually conducted this study in 2 environments. The first one was the study that we did in our local environment. So in our local environment, we deployed a CoreDNS local resolver supporting DO, DOT, and DOC. And also we used a tool called as Q to query the resolver. And the result that we got actually said DOC performs better than that of DOT and DO. So then we moved on to the analysis that I'm presenting it today. So we actually connected to the resolver that are there in internet today, and then we got our metrics. So yeah, the first experiment that we did is to take the measurement from the internet connected resolver. So basically this whole study is divided into 2 parts. First one is discovery phase and then the metric gathering phase. So in discovery phase, we are actually discovering the resolver that are present. So in order to do that, we are running a Z-map that scans the IPv4 address space for the TCP port 853 and TCP port 443. So once we get our list of the IP address that has the port open, so we are actually sending a DNS query. So if we are getting any valid response from the IP address, then we are classifying it as a resolver. If not, then we are not considering it in our analysis. Yeah, and for the quick, when we are conducting this study, actually ZMAP was not really, supporting the quick in their, code. So we actually had to send an invalid version packet to the IP address. So if we are getting the version negotiation, packet back from the server, then we are considering it as a quick capable IP address. So once we get the list of quick capable IP address, we are actually, sending it through the tool called verify.doc, which actually uses the application layer protocol negotiation concept that is there in the TLS handshake and telling if it's a doc capable or not. So with this method, we were actually able to find out 348 resolver that supports all the three protocols all over the world. So this is basically the intersection that we are taking for the analysis. And then we have the metric collection phase where we are, querying the resolvers using the DNS perf tool and for the A record for google.com. So with the, the result that we are getting is in the form of database and then we are actually visualizing it through the Python scripts. You can see the blue dot that is there is a vantage point from which we are doing the analysis. And the red dots are the resolvers. From the first part, we actually got to know that the major DNS resolver that supports all these three protocols are from NextDNS, Privacy First, and the AdGuard. So in order to know about the performance better, we actually extensively queried those resolvers. So in order to do this, we used the tools called Q and GoDNS bench. The thing is, Q sends a request sequentially, whereas GoDNS sends the request parallelly. So we sent 500 random queries to the resolvers, that is NextDNS, Privacy First, and AdGuard. So using Q. So next we had to send 1,000 random queries for A record in 10 parallel connection using GoDNS. So yeah, this is the result that we got basically. These two are the CDF graph representing the handshake time and the response time. So if you can see in the handshake time, it's the doc handshake time is so negligible. So that means that can be interpreted as the doc resolvers are already supporting the zero RTT that is offered by Quick, and also the handshake for DNS over TLS and DNS over HTTPS is very similar because the handshakes are pretty similar for both of them. And then there is response time. Response time is similar for all these three protocols. So we have the total time that it takes for each DNS transaction. So here the lesser, the doc has the best total resolution time. This is because of the lesser handshake time that the doc, gives. So this is the result that we got by extensively querying the AdGuard and AdGuard, NextDNS, and Privacy First DNS. You can see even here the doc, resolves the query faster than the other two resolvers, and the NextDNS actually gives a better resolution. Probably the reason could be that the NextDNS resolver is, location is near to our vantage point than the other DNS server. So yeah, there are two major, important works that we have referred for our analysis. The first one is Prevalence of DNS over HTTPS by Carl Hannock, and the second one is First Look at DNS over Quick by Mike Persek. So basically, the analysis methods, in order to discover the resolver, we have adopted from the first look at DNS over Quick by Mike Persek. So the trend that we saw was the increasing number of resolver configured with doc and do. So this was the you know, what do you say, the upside of the DNS over encryption, that is the faster query resolution with the privacy. So yeah, can this, you know, privacy provided by DNS over encryption be misused? The clear-cut answer is yes. So it was already harder to find this, you know, attack like data exfiltration or C2 communication over a plain DNS itself. Now that it is encrypted, it makes it even harder because we only have two kinds of feature for us to investigate, right? That is temporal-based and the length-based feature. So it really makes it harder for anyone in order to understand if the attack is really happening or not. And for example, the recent attacks on encrypted protocols are that Godlua backdoor malware, you know, abused DNS over HTTPS, and also the Camel Door Linux backdoor utilized this DNS over HTTPS tunneling for C2 communication. Yeah, the future research scope. So DNS over Quick offer a good query resolution time with the significant benefits by protecting the user privacy. But also, as I said, the encryption that is there in the DNS over Quick can, you know, possess challenge in inspecting the attack or threat actors. So the future work, one of the future work after this could be, you know, investigating the vulnerability of DNS over Quick. So the vulnerabilities of DNS over HTTPS is already being, you know, investigated by doing many more research. But yeah, DNS over Quick still has to be investigated. Yeah, these are some of my references. Thank you. And yeah, any questions and any critical suggestion would be, you know, well received. Thank you.
Thank you, Molia, for such an insightful session. Next up, I'd like to invite SANOG Chair, Mr. Rupesh Shrestha, yet again, to share the SANOG update.
Yes, this has been my ritual in every SANOG since last many years, that I give the SANOG update of what's happening in SANOG till now. Before I start the presentation, I would also like to thank so many people like who are staying back. This is the last presentation, I guarantee you. So there's nothing after this, right? So we'll be completing the SANOG41 after this. I'll just quickly do the SANOG update, and I have to thank few people, which I'll do after this update. So I'll start with this update. For those who do not know what SANOG is, just a brief format on what SANOG is. SANOG is a South Asian Network Operators Group. We do 2 events every year, one tentatively around April, May, and another one would be on October, November time period. We move around, we go around different cities of South Asia, and we work with the local NOGs, our local partners in each of the countries. 2022 SANOG 38 onwards, we used to do like 5 days of workshop, 2 days of tutorial, and then a day of conference. But we changed the pattern a little bit since 2022. We only have 4 days of workshop now, and to make it very effective, 1 or 2 days of conference after that or before that. In SANOG, we have 2 committees. Primarily, we have 2 committees. One is called Program Committee. Another one is a Fellowship Committee. For current Program Committee, Dr. Philip Smith, Sumon Ahmed Sabir, and Divya Khatiwada are the co-chairs. And for Fellowship Committee, Kizus Marjan and Suhasini are the co-chairs. But there are a lot of other committee members in both Program Committee as well as Fellowship Committee. The papers that you submit are goes through the paper submission system and are evaluated by each and every program committee members. Similarly, for the fellowship program also, we received around 150 applications this time, out of which 8 fellows were selected. And those fellowship applications are also reviewed by around 8 to 10 people. Okay, SANOG we started in 2003 in Kathmandu in the month of January. Then we went to Sri Lanka, India, and then Kathmandu and so on. And we are currently in the 41st edition of SANOG. So far we've done 41 events, out of which probably two was club along with Apricot, and 2 was more online event. 2 were online events. So total host countries, 6. We've not gone to Maldives yet, which we would love to go in future. The fellowship program has been awarded to 468 people so far. Total number of workshop tracks conducted, 106 workshop tracks conducted till date. Total workshop participants, as I said in my opening welcome remark, we've trained 3,177 workshop participants so far. There are majorly generally categorized into 14 workshop tracks so far, which are as these, out of which IPv4, V6, BGP routing, we've conducted 30 workshops so far, the most popular. And these workshops are based on the host's demand, the country or the city where we do this event. We ask the community over there, and then based on the community's suggestion, we set the workshop for that particular event. Followed by network security, which is again another very popular workshop track, and DNS and MPLS. So this time we had, last 4 days workshop, we had network monitoring and management, then we have DNS workshop, and then we have IPv6, BGP, and RPKI. So this is the number of times that we have hosted SANOG events in different countries, 6 different countries. Bangladesh, we have done it for 6 times, Bhutan in 4 times. In India, this is the 12th time we are doing it. Nepal 7 times, Pakistan and Sri Lanka 5 times each. We've also started a SANOG CERT initiative. Today we had a first meeting among the South Asian CERTs from India, Bangladesh, Bhutan, Sri Lanka, Nepal, and Pakistan. So we're also working very closely with these CERTs and then with the other regional CERTs also. So we plan to do that to continue working to have a better information sharing, to help them actively participate, help in empowering them and training them for the further make them more resourceful. So these are the initiatives. So as I said in my opening remarks also, we also were thinking about like having some kind of a policy advocacy within the SANOG. So those are the few things that SANOG would be working on in coming days. So this is just a brief outline of what we've done so far and what we've been doing. SANOG39, we did it in Bangladesh, hugely successful there. Then we did another one recently, was SANOG40, which was in Colombo, Sri Lanka. Again, yet another successful event. And this one in Mumbai, I would also term it as hugely successful, more than expected. I would rather say the workshop was, I don't know why this font is like jumbled up. So the workshop was hugely successful. 100+ people attended, full packed. We didn't have even a single seat empty. So greatly successful workshop. Conference, we set it for 2 days, and we still had, like, the program committee was still struggling to select the right good paper for that matter, right? So we had to reject, or we had to put a lot of papers in the pending list. So thank you to all the paper submitters, presenters, speakers who presented the good paper. Thanks to instructors for what do you call that? Working, training, and putting an effort to train making the skillful resources without any, they all are doing voluntarily, right? So all the volunteers who've come up front and then started doing the training for workshop, I cannot thank you more. So they are the very important pillar of how SANOG and what SANOG does. It's completely a community event. We do not pay the instructors, but the instructors put in more than 100% effort to train all the people. And the feedback that we've received and we've been receiving from the participants of the workshop are excellent. So thank you all the instructors too. Also thanks to INNOG and INNOG's working group, secretariat team, who have put together all the local resources and local support and all the support. So thank you very much. Especially thanks Natasha for tirelessly working through the whole process. Pankajji and Natasha, they've been like pillars of this for hosting this event. Sushil and all the program, the working group, INNOG working group. I can see Rajeshji also here, Vijay, so everyone, Rahul. So if I missed names, so please forgive me. But everyone, thank you very much. All the secretariat team, thanks. Thank you very much for all the effort that you put in. Who did I miss? Sponsors, of course. I've already thanked the sponsors. Participants, thanks to all the participants who've participated in this SANOG and made this a successful event. Also thanks to, who else? My co-organizers in SANOG, Jihadul Kabir Bhai, Dr. Phyllis Smith, Gaurav. So thanks to them as well. Thanks a lot for making this event successful and helping through the whole process of making this event successful. I really apologize if I missed out anybody. APNIC. APNIC is by default. Without APNIC, I think thank you Parar sir also and the APNIC team and everyone, I think, in fact. I've already mentioned a lot of names during the sponsorship appreciation also, the trainers from APNIC, cities from APNIC. So I've already mentioned. Thanks to AV team, great work guys. I mean, this is a great setup and I know that they've worked around they started around 1 a.m. at night. So they worked over the midnight and they finished this everything. Thanks to our internet sponsor who's provided us with a good internet connectivity. Thanks to hotel for providing good food and making us stay comfortable. Thanks to both the Fern Hotel and Trident as well. And Natasha, did I miss anybody else? iSpy. ISB Association of India. I'm not the spy, okay? I'm not spy, so ISP Association of India, how can I forget that? So thanks ISP Association of India for patronizing this event and this, and especially patronizing the INNOG, supporting INNOG to reach to the level where it is now. And I think this support will help a long way for INNOG to go forward and be a very important part of the community in a longer run. Thank you very much. And if I've missed anything or anybody, please take it as my appreciation and thanks and whatever. So in general, this is what I wanted to say. Thank you very much for all. Thank you all for participating. I'll give it to the, give the mic to Priya for do the closing. Thank you.
Thank you so much, Mr. Rupesh, for your address. And with that, ladies and gentlemen, we come to an end of the 41st edition of the South Asian Network Operators Group. Can we give a big round of applause for your own self for making it to this event and making this event a huge success? I believe that each one has contributed to the success of this edition. And yes, we are really looking forward to host you all again for our next edition. That is SANOG42. So again, a round of applause for everyone once again, to the entire organizing team of SANOG41 for making this event a huge success. I would like to thank the entire team for having me to host this wonderful and warm audience. I'd like to especially thank Natasha for the continuous trust and support. And yes, with that, this is Priya Shramankar signing off for this conference, and I hope you all have a good evening ahead. Thank you. Thank you so much.